Hello, everybody. Good evening, good morning, depending on where you are. Welcome to the Propeller Live Forum. Today's Wednesday, October 18th, 2023, 1 o'clock p.m. Pacific time. So we'll let people come on in, get a seat. We had quite a few signups, I think around 60 or 70. Marty must be very popular with MakerPlot. So before we get rolling with that, let's just do a little bit of housekeeping, and I'm going to sell you some things. So today and through the weekend, the microbus, P2 to microbus boards are all on sale. That includes like 30 different products. And I will paste a link in the chat if I can find it again, or maybe someone else can do that for me. Because I seem to have lost my chat. Anyway, just going to give that just a minute and see if I can get that back. Okay, there it is. All right. So there's that. 30% off everything, all kinds of sensors, our adapter boards, and our adapter board connects the click boards to any of the parallax boards. So come and get them, 30%, 30 different boards. Next, you may have seen this news story. So thanks to Johnny Mack for drawing some attention to this in the last Propeller Live Forum. This is yet another alternative IDE. It's the Microsoft Spin Tools IDE program. Works for the P1 and P2. And there is a page for it on the news article. And I'll also put that into the chat right now in case you want to read about it. It's really easy to use. I hooked it up and got it running quick, which says something. Laugh and laugh. I'm the business guy.
Ken, that means, hey,
It's okay. As long as I set a new low bar, we'll know everybody is welcome. So today, here's what we're talking about. First, Michael will share the OBEX for us, which we have been working on since March in some form. But we had him on a lot of other projects between then and now. So this took a long time. The original OBEX was built in a system called Drupal. It became very hard to maintain, became a spam repository. And then through changing of our websites and whatever, it got lost, taken offline, which is very unfortunate. And then we tried to get adoption on this. I am enabling screen sharing, by the way. Oh yeah, I'll do that for presenters too, for sure, Stephen. Anyway, OBEX got lost and we tried to bring it back on GitHub. That wasn't so popular. There's a lot of good stuff on our GitHub and other GitHubs, but this is the repository that we're now really supporting, and it will become the one-stop all for all Propeller 1 and 2 source code software and documentation. So Michael's going to share that. Then our main topic is MakerPlot, or MakerPlot-J as it's now called, with Martin Hebel. So I'll introduce him before he starts. And then Nick Benezan will share a project he's working on. It's the all-in-one CNC machine controller. It's using the P2, and you've seen this probably on our forums. And then Stephen has a Visual Studio Code update, or as he just said in the forums a few minutes ago, big news in today's P2 live forum. See you there. So we'll see what that's about. And then Chip has been working on USB, and Chip is here too. So cool. All right. So Michael.
Ken, can I interrupt for 1 second,
Yes,
please?
please, Martin.
That new IDE, I'm on your website. Where is that?
The web address for it is so I will paste this in chat and it should take you to the Microsoft page.
Okay, thank you.
You got it. And someone else can yell it out if they know it offhand. I think it might just be Microsoft. Any other questions before we turn over to Michael? Okay, Michael, all you. You should have screen sharing enabled. He does. Michael, do you have a voice? Looks like he is muted. I'll unmute him.
There you go. I'm muted.
Okay, welcome back.
Welcome to the real world. So, so Propeller Hub, as I've just read, we should be calling it now. Well, I think that's how it's going to go. I've removed the basic stamp and the microbit things from the site this morning. So this will be a single resource for Propeller stuff. And yeah, so this is the landing page, hub.parallax.com. Anyone can register. And ultimately, there'll be news articles, customer projects, things like that on the front page. It's not really arranged yet because there's really no content to arrange. So I've just sort of put a couple of articles there, poached from the forum, but we'll get to adding articles there. So that's kind of a news and customer projects type interface at the front. And then we can just click through to OBEX. There's a couple of links there, or you can click here. And that takes us to the OBEX. So this is the main thing for now that we've sort of fleshed out. And as you can see, table of OBEX stuff. There's just scroll to the bottom. There's 793 objects at the minute. That's basically an import from what we had. And yes, Ada, I will sort out your OPN. So there are a couple of duplicates where they've had duplicate categories, and it's not been very consistent in the way the GitHub files stored those. So some things have ended up twice, but we'll sort that out. Small details. But yeah, so basically you can register here and you can just see your projects. Here's one that let's pick on something that might have a bit of content to it. So you can just click on very easily. You can see the object ID. You can see the date that it was put in. Someone on the forum earlier mentioned that we could also have that date on the table. And yes, for sure, we'll add it in there. The author at the moment, it just says added by archiver. There's no link to the author because we didn't have that. But as people register on here, I'll just sort of go through and patch them over so that the original author will be linked back in. Another thing I've done is started the numbering from 3000 onwards because there's an awful lot of old Parallax links everywhere in the shop and in the forums which used the old original OBEX numbering. And it would be nice if we could sort of hook those back in ultimately in the future. So I've made allowance for that and made sure that we've started numbering higher than any of the older stuff. So that's why it starts at 3000.
Is there a way to actually get to an object from its ID? Because the search doesn't do that.
Yeah, you can do slash OBEX well, maybe that's not active for you yet, but yeah, ultimately you can do OBEX the number. Yeah, that actually might not be active at the minute, but yeah, ultimately you can. Yeah, so that's kind of it really. I mean, as you can see, it is what it is. And here's your content. It's markdown script, but people can just use plain text as well. Obviously, there's some formatting to improve. You can access all of the files individually. So if you click on a file, you can get a preview and see what's going on. And some people like to look at individual files that way. But you can also just click the big zip archive download button and download all the files in one go. You can probably do it from there as well if you wanted. Or you can do it from the
I
table.
don't think the zip downloads actually work.
Yeah, it does now.
Does it?
Click there. And, well, we're missing a little graphic that's a spinning circle, but otherwise, there you go. There it is, save.
Nice.
It happens. It eventually happens.
That qualifies as working.
We just want a little spinner. Yeah, it all works. You just want a little
spinner. It's named after the object ID. If I change it back to the B-movie script, will it give me a file with that name?
That's right. Are they in bungalows, are they?
Yeah, so that's all working. You can if you want to, and once you register, you just go to OBEX, and once you register, you'll get a confirmation email, and within sort of a couple of hours usually, or certainly within 12 hours, you'll get another email saying that you have full power. And you can, once you get that, you'll be able to click here and you'll see this menu pop up, add OBEX entry. So you can just click there, type in a title, type in a short description, and then just click the tabs to say what it is, category, languages that are involved. You can have multiple ticks if you want. And then choose your license. It defaults to MIT because that's generally used by Parallax stuff. But if you prefer to sort of not have a license or specify your own license in the attachments, then of course just click Other. And write your content here, content, I meant to say here. And as I say, that's all Markdown aware. If you're not sure about the syntax, you can just press things here to help you with that. You can click Preview to sort of roughly see what's going on. It's not the best Markdown previewer in the world, but it was instant and free. So that's what we've gone with. And obviously over time, we might improve it for Parallax's specific purposes, but it gives you a pretty good quick go of most things. Here, this is your adding your files section, so you can drag and drop files or folders in there, or you can click plus if you prefer to search for files and folders using your file system, whatever you prefer. Tags, it would be nice to have a little list of sort of already known tags coming up, but we're not there yet. But certainly you can type in, whatever tags you want. And if it doesn't exist, it will generate it. If it does exist, it'll, and there you go. So, and you've now created a post. So I think that's about all really. We've started a thread on the forum just to sort of rattle through things that people notice and anything that, you want changed. At some point, it might be nice to do a bit of styling, with colors and layout and get rid of excessive white space and stuff like that. And if anyone wants to sort of get involved in that, then feel free to shout. Otherwise, we'll just sort of work through it. But yeah, open to questions and comments on the forum, of course. And I think that's about all, really. Hopefully that's a good start for everyone. All we need now is lots of content.
We're very happy to see this, Michael.
Yeah, it looks good.
It really does look good.
It's as simple as possible at the moment. There's actually an awful lot of good ideas. Well, Stephen, who's just spoken, and a couple other guys, previous meetings, which have not been forgotten. But obviously, we just start with as basic as possible, and then we'll just layer it on as we go. So yeah.
Round of applause for Michael.
Can I ask a question?
Yep.
So is there a way on this? Because like I have a bunch of drivers that were in the GitHub one, they're not in here. Is there a thought process moving forward to possibly be able to hook these into GitHub or any of the Git repositories so that when they get updated, they can automatically be imported back in, or are we going to have to resubmit them every time we do an update?
So are you saying that they're in your own GitHub repository rather than the existing Parallax one?
No, they are in the GitHub Parallax one, but they're also in mine, and they just did a hook. They just pulled mine in, but they didn't show up in this list. But I'm just asking, is there moving forward? Would it be possible to hook this up so we can just put our GitHub repo in there and have it pull it automatically?
It's possible, and it was something that I had at the very beginning as sort of making sure we could do it if we wanted to. So it is possible. I think, to be fair, that's probably a good way down the road if it happens, because yeah, there's probably a lot of other things first that we want to get done first. But yeah, it's definitely possible. I mean, I used a GitHub importer to import all of the Parallax GitHub objects, as you can see here. So it's not, it wouldn't be impossible to change the URL and point that to your site.
Oh, wow, the error messages are working now.
But just out of interest, Greg, I don't know if you've looked, but are any of your objects in here?
Yeah, that ILI 9341, I was part of that. And I've got a couple other, that Max, the one right above that too. I believe the Max one is mine.
Uh-huh.
I've obtained your display drivers from the old OBEX, Greg.
Yeah.
Yeah. I can see
Well,
your,
I'm gonna encourage Greg and all these contributors out there to use this and keep it on their OBEX as well, and just refer to your OBEX for more details if you could do that when you post here.
Yeah, no, I'll do that. I'll have to pull them all down and re-zip them up. But I was just curious if that was a thought process maybe in the future, because it would make things a lot easier to be able to log in, create a new object, just put my Git URL in there and have it pull it in automatically.
Yeah, but that definitely, obviously, that would be nice. One of the, I think, what really the only issue I came up against importing the GitHub stuff is that there's not been any consistency in the way the README files are written, which makes sense because there isn't a template for that. So obviously, what we're creating here aims to solve that niggle because now everything is strictly templated. But yeah, linking into stuff, it does create that problem. So I don't know if possibly what we might want to do is sort of specify a README template that people should use. And if they adhere to that, then maybe, they could type in a URL and it could suck them in, something like that. But that's, but other than that, yeah, it's fine. And I'm not sure if I mentioned, but just as it comes to mind that, again, if there's people who've got stuff on this new OBEX and they would like to have them linked to their new account on this new OBEX, then I'll try to get to that ultimately anyway. But if they, it might help me anyway, or it might help get it done quicker if you just send me a comma delimited list of all the object numbers that are yours and your new username on the OBEX. And I'm more than happy just to, patch those over to the appropriate username.
This one here that you're looking at is kind of an old one. I think somebody gathered, because there was 4 or 5 versions of it floating around. Somebody gathered them all and put them together. I don't remember who it was. But maybe it was Cluso, I'm not sure.
Yeah, you see, this is another one with your name in. So I mean,
yeah,
where I can find people and it's obvious, I could sort of do that. But I mean, here's a good example where the tags were not consistent, so it's ended up not doing a very good job of importing it. Other ones, it's been more, well, what's consistent. But anyway, this is, and again, on the odd weekend here or there, I'll just sort of flick through these and tidy these up. It obviously won't take very long, but a bit of a.
I logged in last night and created an account and was poking around in there when I got the email that it was up.
Yeah.
Thanks, Greg. Mike, I have a question for you.
Which function's supposed to be working?
Sorry, which function?
Just the search. I tried putting in P1 PASM display and it says no matching objects, but I know for sure we have display objects for the P1.
Well, it might not search with spaces. I'm not sure. I haven't tried, but I mean, you could certainly try P1, PASM, and display, I guess. Oh, I see. You've done it like that. Yeah. No, there's no objects. Yeah. So in that case, it's just a question of it's just probably a case that it's not been, with the bulk import, it hasn't tagged everything perfectly.
Yeah, so there may be a lot of missing P1 stuff. I mean, just at first glance, it seems like there's a lot of missing P1 stuff, and so that's not intentional. All the P1 stuff from the GitHub old repo is supposed to find its way in here.
Yeah, it should all be here, but it's interesting that you've picked on display because seemingly there's no P1 display. But if we go to P1, for example,
well, I don't see any P1 data storage either. There's a lot of fun. There's no P1 human inputs. I'm just doing PASM.
Yeah, the categories are like they got messed up somehow, I think.
Yeah, there's 700 objects. It might be that there's some there. Might be anyway. Yeah.
So Michael, might be a good time to point out that this is a WordPress tool, and anybody we give permission to can come in and change this and help us with these categories, right?
Yeah, I mean, it'd be nice if the as much as done as possible in the first instance in terms of bulk. But yeah, for sure. If anyone fancies doing a bit of editing going through, then yeah, give us a PM and we'll hook you up
Yeah, we're actively recruiting for a non-paying position here. Anyone interested? We got plenty of work.
Can you dump that out to like a CSV file or something?
Did
You
you say
could
it's
do
implemented in word stress?
word stress, yeah.
Because if you could dump this out, to a CSV file, it might make it easier then you don't have to give everybody permissions to the back end. You could just dump it to a CSV and we can hack on the file and then you could just re-import it.
Yeah. Yeah. Well, exporting it is very simple. Re-importing might be something else, but might take some thought. But yeah, not much thought, but just some thought. But yeah.
Michael, a question for you.
It could be something as simple as just the P1 import was labeled as video instead of display or something like that. And so it doesn't find it when you search or when you use the drop down for display. Could it be something that simple? Or?
Yeah, I don't know. I'm actually a bit suspicious of this because I would have expected to see some, but I'll have to look at the GitHub and see why or what what the difference is. Oh, we've got some fresh shrimp here. I'll have to look at and see what there is. But yeah, it's good. I'll add it to the list to check through. I haven't actually checked or verified anything yet, so Ken very kindly launched it prior to it actually being finished and prior to it actually being online.
That's a way to get engineering sped up.
Yeah. So yeah. So that's
how the business goes. The product isn't finished, but it has to release.
Yeah.
So thanks everybody for helping us here.
Numbers go sound.
We welcome your input.
I think I think roughly I think we'll just spend a few days now rolling through it very quickly and taking note of stuff on the forum and rattling through them, including making sure that Ada can't hack the OB numbers anymore. And yeah.
All right. Shall we continue on?
Yep.
Okay, and Michael, as we make changes and improvements to it, let me know and I'll keep featuring that.
Okay.
So that we can inform people that it's growing and evolving, which is what it's going to do for the remainder of its lifetime and our lifetime.
Yeah, that's the hope. And just to reiterate, if anyone has stuff that they want to post on there now, please do feel free. And that would be great to start to see content going in. It definitely helps to shape how things are laid out as well, having content. And for sure, we're not going to delete any of the content now. So apart from Ada's funny business this afternoon, but for everyone else, sorry, Ada. Yeah.
I mean, it literally says in the bit, please delete when done. So like.
Okay, next up, Martin Hebel. I'm going to be drawing a little bit of attention to you because I think highly of you. So if you're like many others here and you're very humble and don't like that, but you've made a lot of contributions to Parallax and our community for so many years. So I'm showing your picture here of your either hot dog or your t-shirt shooter that you use at SIU. And you're a professor, associate professor at SIU, Southern Illinois University in Carbondale, and you've been there for 25 years. And our first work together was actually this. People might remember the Stamps in Class program way back in late 1999, early 2000, and we put out many books like this that were tutorials with the basic Stamp 2 on the Board of Education. They're very popular. And Marty and his colleague Will Davenport wrote this one it was originally called Industrial Control, then he renamed it Process Control, and it was a 300-page book about using PID. And this was really cool, and I learned a lot from this, and central to it was this circuit right here. So we learned how to do PID control with a resistor that was a heater, and it was in a film canister, and there is a LM34 temperature sensor. I think that's a temperature sensor inside of that film canister, and then a fan acting as an external disturbance. And through this circuit, we had a complete PID system, and it was a visual. By the way, here's a circuit on the left. It was absolutely used every single hole on that breadboard, just about. And we would take this to educator courses, and teachers would wire it up and get it working. And then they would install the software at the time called StampPlot, which is shown on the right. And then you see on the top part of that in StampPlot, that's the temperature. And then the set point, I think the bottom was like the PWM or the heater of the resistor. Marty, you'll remember.
I think it was drive for the heater.
And drive for the heater. Okay. Super cool. And I personally learned a lot from this. Didn't know what PID was before. And then you also made this very cool software called PLX Stack. And I'm showing off all the free things because, as Marty figured out, eventually you can't do everything for free forever. And that kind of got us to where we are today with MakerPlot. But Parallax Stack, or PLX Stack, is available right now for free on our site. And this is a way to stream data into Excel. And this is also really cool, part of all of his series. So I'm going to post a link to that in the chat in case you all want to go get it.
You don't want that, okay? That doesn't make me any money. So.
Okay. All right. So more on that coming. And then you also did this. You just can't stop. So around 2006 or 7, we put this book together with Andre Lamotte and with Chip and you and Jeff Martin and Joshua Hines and Shane Avery and Andy Lindsay. That book's available today. And you contributed in that a really nice, I think it was an XB chapter on wireless. Right. Okay. Yeah, using the Propeller, and that was cool. And then you couldn't stop. And then you wrote this massive book, and I'll get links to all these in the chat when you start going. This was the XB project book, and it was a complete tutorial on spin and I think PBasic on how to use XB. And you got us through XC2U setup, and then you showed us mesh networking, XB, Zigbee, and then you had this project with a BowBot and a joystick, and that was really cool. That book is, of course, all the stuff I'm showing you is available for download, and I'll grab the links when you're rolling. And here's Marty Hebel, and Marty prefers dogs over cats. He likes Thanksgiving food, and his first album ever owned was Elton John's Greatest Hits. Okay, and if you aren't fully embarrassed and you're still willing to talk and share the feature of the day, go for it.
Okay, welcome all. Let's see, do I have control here? Oh, screen share. Okay, as Ken mentioned, I am a professor, so therefore we need some PowerPoints going on here. So I'm going to talk about using Propeller tool with a Propeller 2 with MakerPlot-J. It's my latest software. And as Ken already listed off most of my things with Parallax, but here's a pretty full list of the various things I've been involved with. And I'm going to turn my pointer on here real quick. Hold on. Annotate. There we go. But when COVID lockdowns hit, StampPlot, which became MakerPlot, was a good 20-some years old, and it just needed an update. So when COVID lockdowns hit, I started a complete rewrite of it in Java. So now it's MakerPlot-J. Get back to my slide here. There we go. Okay, so today I'm going to talk about a little bit about what MakerPlot-J is all about, the basic use of it, how we can send analog, digital, and message data from the P2 for plotting, metering, logging, and such. I'll demonstrate some interactive control with the P2 with MakerPlot-J so we can monitor and control things with it. Also, I'll do one on high-speed data acquisition and dumping of that data. So we'll do some really quick sampling with the P2 and then dump that data to MakerPlot so we can see it. And also Ken, told me to give me brownie points if I did something with a micro SD card. So I've got one with logging of data from the P2 to the micro SD, then dumping that to MakerPlot-J. And all these, I'll go to MakerPlot-J. Let me switch to it once. All of these are, I got this thing in my way. Where's it at? But once you open MakerPlot-J, if you go to folders and then open microcode folder, the current installation has Propeller 2 spin, and these are all examples I'll be going through today with the required object files for them. So if you want to play with this stuff or just take what's there and use it, it's all part of the download now. Okay, and it's available at MakerPlot-J.com. So MakerPlot-J is fully customizable. It's an HMI, human machine interface for microcontroller monitoring and control, or sometimes called SCADA. Nearly all features can be accessed via serial data. I'll do a lot of things, on the screen, but pretty much every aspect of the software can be controlled through serial data from the P2 or other processors. But we can do plotting of analog data, digital data, metering, logging of the data. We can create from the P2, we can create an actual interface from it. There's drawings for lines and circles and do images and such on various locations on the plot, the backgrounds, the canvas controls and such. It is drag and drop. It's not really drag and drop, it's actually click and place. Interface development. We can easily change properties of controls and code from the controller or through the editor itself. Auto update of control values. We can have controls that automatically update based upon the data that's coming in. And there is contextual help. So when you write some MakerPlot code, there's some contextual help that help you write what you need to. And it does support multiple serial ports that sometimes people are interested in. I did play with it the other day, and it seems like there's a little glitch using multiple ports. Sometimes it kind of locks up for a few seconds. I need to look at. And it's still in beta, by the way. So any glitches, I just say it's still in beta, but it is available for download. Okay, so just some real basics, and this is starting from way back from Stampplot Lite. I wrote over a weekend for Parallax for our first book that Ken talked about. But when we send data to it, we can send analog data, and that's just comma separated values, so 10, 20, 30, and everything needs to end with a carriage return. If I want to send some digital data for plotting or using it in our interface, it starts off with a % sign, then just your digital data. And for both these, it can be up to 100 values. So we can only plot 10 at once on any one plot. Supports control and drawing instructions, so like exclamation plot reset to tell that plot to reset. So we could send that from Propeller and reset the plot through the code. Or we can update a meter manually with like meter voltage is equal to 20. So that meter will display the value of 20 or indicate value of 20, or draw a circle on the plot or something. So everything is, again, we can do everything through code. Messages, we can just send messages to be displayed in a message box or used by it. And that's anything that doesn't meet, a specialized use like exclamations or anything else. So we can send messages to be seen, so we know stats of what's going out the system. Accessing values, both the incoming data and all the MakerPlot values can be accessed through brackets. So such as meter voltage, just say it's equal to that analog in value 0, which would be that value of 10 for analog in 0, analog in 1, analog in 2, and so on and so forth. Or show me the value of plot channel 0 in the debug window. So go to the plot, get its channel 0 value. So I'll show a real quick example here of just doing an interface. Then we'll move on to the Propeller specific stuff. So I can make a plot. And when you first open it, it does come up with a bunch of sample plots. You can just select and just click on one of these and it loads it up. But you can create your own very easily. And minimize that screen a little bit here. Minimize that, get my way. So we'll just do a new interface real quick and toss a few things on there. Delete it all, yes, please. So I'm going to hit F2 to bring up my controls palette. Okay, well, let's see. We need a serial port on here, so we'll grab a serial port. We'll just name it serial. Toss it down here somewhere. We'll go to F2 again. We want an analog plot, and I'll just call it plot. Keep it simple. Give it a title. I'll call it Propeller, if I can spell, demo. So it's got a title to it, and just draw that on the plot somewhere. A little space over there. Okay, so we got the Propeller demo name up there for it, for that title of that interface. Let's go ahead and we'll just toss a meter on there real quick. So we'll go back here, and there's a lot of different controls we can use, all the standard controls. There's timers here. We're going to set a timer for a single shot, or a continual timer, or data logger. So we'll take a look at that, how to log data that's coming in. Or we got a bunch of image buttons for various different buttons, either momentary or toggle buttons, or radio buttons we can use, or an icon format if you like icons. And all these graphics are just graphics. You can actually create your own and assign those yourself. For example, when I put this button on here, I'll just go to the default stuff, test, and we'll draw it over here somewhere. When I place that button, then the properties come up for it. And through the properties, we can change the text or assign a hotkey to it, give it a certain sound when it's clicked. But its icons, all its icons are just image files. So you can create your own images and create your own buttons for things and just assign those images to it through it. The help files go through and explain how, if you're going to package this up for others, how to do it properly so you keep all those files together if you do your own media and such. So either icon or pressed or hover type images for it. So we hover over it, kind of changes its color, just a different image. There's a lot of different settings for it, borders and whatnot, font names, and you can change the font and everything else. With other controls, we can assign a value to it, such as a text box or meter, what value is going to use, like AN0. So it automatically grabs that analog value and displays it. And we can write event code for that. So when I press that button, it does something. For example, just to like reset that plot, I'll open up the editor for it. And so I can say, do exclamation, and it shows me over here, it shows me all the available, if there's any variables I've created, all the controls on the plot. Then for right now, it's for the main area, the various instructions we can do for it, and various properties and such. So everything's listed for you. So if we want to do something for the plot, we hit plot, do a dot. It shows us like we can reset the plot, or shift up or shift down, or double or half it, or save it, or do various things. So I'll just do a reset on this. So reset, I can use control space to autocomplete for me. And then we update the code. And I don't have anything on there right now. We'll go ahead and put a little bit of data on here. So I'm going to exit out of edit mode with F9. I'll bring in the debug window, which is F4, and just plot a couple values. So we'll just do a couple values here, get something on the screen. There it is, coming on the right side over there. It's way over there. Let's see, 20, 50, 80, 90, whatever. Well, again, those values, I could use the debug window here. We can test everything through debug as well, and send out a bunch of instructions or whatnot. But we've got data, so we'll hit our reset button and make sure that works. We can actually reset it up here, but this is more fun. So reset the plot. So we can pretty quickly write code for it and have those controls do various things for us. Or like we can put here's our meters and such. We can toss a meter up here. Call it meter. Text for the meter. We'll say voltage. And toss that up here. Okay, so we get a meter up there. Through it, it does have some drop downs. We can set the data source. Right now, data source is analog in 0. So that first incoming value. So if we go back to debug, oops, man, type in again, 20, 40, 50. I'm going to edit mode. Edit mode again. F9. So typing that value of 20, it indicates 20. So it's just reading that data directly, and it starts metering our data. So we do 50, 60, 70, and it just updates as that data comes in, and we can meter whatever we want. Okay. And there's all kinds of controls on here for controlling things we can do. A shifting plot or a single sweep, it'll keep resetting, or we can stop at max just so we can kind of see that and have it stop at a certain time and be able to analyze our data and such. There's some videos online. If you go to my website, there's a bunch of videos where I talk through various aspects of it. So I won't drone on too much about the mechanisms of this. But we can do a lot of things with it. For example, I talked about reading values, F4. So if I want to get that value, I can do question mark, do the meter dot value. I think it's value. I can't remember. It's actually default. By default, it just reads the meter value. So I can return and get that value of 20 that the meter is currently reading. And that's true for all the controls. You can just access their values. Okay, so that's how we start building an interface. So we just save it, and then we can reopen it later. And that's about all it takes to get going with an interface. Okay, so we'll go back to the selection interface. We'll hit our PowerPoint real quick here. Okay, so pretty easy to start developing interfaces with it. And once it's on there, you can drag it around and resize it pretty easily, move things around, delete things. It's been cleaned up quite a bit from the original StamPlot, MakerPlot, everything I didn't like about that. I focused on fixing all those things I didn't like about the original, and Java helped a lot doing that with some speed. So let's start looking at some Propeller examples. Okay, so the first one is just plotting some analog and digital data from the Propeller. So it's going to send a starting string message, send 3 analog values, send 4 bits for plotting and monitoring. And that, just for fun, after 200 samples, the Propeller will reset the plot so we can see the next 200. Then we look at logging with it and applying math to incoming data, which helps out when you're kind of limited with your math capabilities on your controller. So let's go ahead and I'll get the right plot. I'll get a plot open for us here. Okay, and let's go over to the Propeller tool. Once I find it, there's my Propeller tool at. Minimize this for a second here. I know it's up there. You can see it up there. Okay, so all I've got for hardware is the P2 eval board, and I've got my function generator running at 1 kilohertz right now, feeding into pin 0 for analog 0. So just the basics up here. When we look at this, I'm using the full duplex serial to get data in and out to MakerPlot. I've got a bunch of variables here. Can I, let's see, can I increase the font size on this a little bit? Text bigger, control up, okay. I'll make that text a little bigger here a couple times. Is that good enough for reading? Okay, but pub main, we just do setup, wait 2 seconds just to allow the serial connection to stabilize. Then I just send a string of starting data, just to send some information. Here, I'm just creating a bunch of variables. I'm using Q, sign, just to create some interesting looking analog data since I don't have any sensors or anything hooked up to this. So I just created 3 analog values here. And then to plot that, I'm just doing the format string 3 values. So sending 3 values of that analog value 1, analog value 2, and analog value 3, ending with a carriage return. That's always important to us. Then for digital, I'm just counting up again on a value, and then I steal 3 bits out of that. So I can grab 3 bits to plot. And so I'm sending 4 4 bits worth of data is bit 3, bit 2, bit 1, bit 0, MSB to LSB to be sent across. And just for fun then, if I've got a counter for going here, if it's greater than 200 cycles through, then it sends a message of another set, and then it sends plot reset. So I send the instruction to MakerPlot to reset the plot and to reset the digital plot if there is one. And then wait 100 milliseconds and repeat that all over again. Okay, so just saying, and we can take a look at this. I'll download it and we'll look at it in the terminal here. And it's always important to look at this just to make sure it's well formatted data. So we have 3 analog values, carriage return, digital values, carriage return, just to make sure it's formatted correctly for MakerPlot. Okay, now we switch over to MakerPlot and we bring in that same data. So we're on COM4 here at 15200, and we connect and give it 2 seconds. So there's MakerPlot grabbing that data. We can grab this, we can scroll it up, scroll it in, analyze a bit closer, but it's just plotting out that data. We can auto zoom it here. If I can get to it, I got a bar in my way right now. There we go. Auto adjust the X and Y axis if we want to, so we can see that data coming in. And then it just, again, all my interfaces are just examples we can do. I'll never be able to make one that fits every possible need out there, so that's why you can build your own. But we can turn off channels either down here or up here. So turn off a channel if we want, and turn them back on. For logging then, this is the logging control here. We can double click and open it. And there's various options up here of when we want to log data. We're going to log when analog data arrives. And when messages arrive, we can have log conditions that if like A and 0 is greater than 100, we can have it log data. So only under specific circumstances, maybe some out of bounds, something happens, so we want to start logging some data, so what's going on with it. So we've got some log conditions we can use. Log data to file. I'll start a new file here, and we'll just call it prop test. And what to log? We can either log data, just to log all analog data or digital data or messages, or we can create a log string and tell exactly what to log by reading those MakerPlot values and logging those values. Also does plot time in seconds, so it puts the time in there as well. We'll do it automatically. So once that's going, we go down here, click log enable. Again, the code for it, if you look at the code for it, it just accesses that control and enables logging for that control or not. So turning on, we can see by time running here, that's updating actively, storing data to a log. And we'll stop it. Then we can open up the log. Opens up a notepad so we can go through and see all this wonderful data that we've stored to a file. And we can add a control up here, a text box up here, so we could rename it here and have it update the meters, the log controls name for it. Images, we can do snapshots as well. So we can give it a name, take a snapshot, and then open up that snapshot. So, oh, I need a picture of that. There it is. Okay, we got it. On the meters, we can set those to the scale of the y-axis there. So we can update that. Has some alarms to it. I can double click a meter to turn on some alarm. I didn't turn on the sound for the control for the zoom, so hopefully maybe that went through. But we can alarm off. We can set those alarm levels, and so we can have some alarm indication going on for us. Okay, I'm going to switch over my interface once I've shown a lot on this one, and our messages are coming in over here. So as those messages come in, they're listed down here, so we can see those messages as they arrive for another set, another set, another set, or whatever we send, so we can pump on, pump off, this happens, that happens, so we can see all those messages coming in. There's also separate windows for those as well with F7. So you can open up a different window and see them if we don't have that on our screen. Okay, let me disconnect here and switch over to one with digital data. So let's go back to our selection. And we'll do one with digital data as well. A little bit different things on this example. So we'll just get this plotting, COM4. And this control belongs to the interface, so I haven't created a way to carry over my settings from interface to interface. But we connect. So you can see digital data as well. So there's our digital data. And again, with these are just indicators here. These are just images. And we're switching between images based upon that digital data. So if I look at the code for this one, again, for its update value, I'm just using dplot.bit3. So it's reading digital plot, it's reading bit3 to indicate as that indicator's value, whether that be bit 2 and bit 1 and bit 0. So that auto update automatically updates all those controls for us. We just tell it what we want to use. Again, with that, we can go in, oops, F3. We can go to the editor, so we can't remember what it is again. Let's see, I need a dplot. And from that, I can look at all kinds of things. Okay, but I want to get out of here. Bit 3, it should be in here somewhere. I don't know where it's at right now. Or maybe I changed things. Maybe it used to be channel. I changed it to bit. Oops, there's bit right there. We'll try channel 0, see if it still works. Haven't tested it in a long time. Update code. Oh, I did 0 instead of 3. So it's, well, there it goes. I don't know. But we want 3 there instead. So I'll just edit it here to be 3. There we go. There we go. That's better. And some bar graphs up here. You can scale these bar graphs for min-max range pretty easily. We can mark text on the plot. So if I see something I like, I can double click it and mark that spot. And we can actually save this plot as a file and reload it later. Let's see. And that's about it for analog and digital plotting. And again, just different features on this one. We can synchronize our plots to this one. So if I change this axis, it'll synchronize to that one. So it'll stay in sync pretty well for us. Or reset both plots. This nice code here. Yeah, that's different. Okay. So that was that example. Let's move on to our next example here. Let's see, where's my PowerPoint at? Interactive control. Okay, it's nice monitoring things, but sometimes we want to control things. And so in this example with the propeller, it reads sliders and switches and analog and digital data. So we can read information from the screen, from the interface, and use it on the propeller to perform some operations. And there's also code in there to convert incoming serial data to integers, since I couldn't find anything that would in the libraries that helped me out. I had to write my own code. It's sad, but it happens. So we'll take a look at that code. This Zoom thing is still in my way, hasn't recessed yet for me. So MPJ interactive control. Okay. So in this one, what I'm doing with that is, again, we're setting up our full duplex serial, wait 2000 milliseconds, stabilize. I flush the RX buffer. Then I send a MakerPlot. I'm going to send the string out to read. So I'm sending a MakerPlot instruction to read. Then I want to read the values of slide 0, slider channel 0, comma, slider channel 1, comma, slider channel 2, 3, rocker bit 3, rocker bit 2, rocker bit 1, rocker bit 0, and then do a carriage return. So MakerPlot gets all those, it replaces the values, turns around and sends that data back out to the propeller. So all we need here is the name of the control to read that control. And so we're reading 7 controls here, 8 controls here. So then I run my code of get decimal CSV, and I'm going to read it in as comma separate values. And this way I don't have to do it once. I could read like I showed down here, I could read one control, get the decimal value, and then do something with it. So I could do a control by control by control, but that takes a lot more time, a lot more back and forth, a lot more chance of error. So I just read them all at once, and then go off and bring those in. So with get decimal, CSV, okay, what's going to basically do is, again, read the incoming data. It just converts it from ASCII over to decimal values with negative possible as well. So negative signs, and then it looks for the carriage return or comma as to return that data back. So with decimal CSV, it's going to read 8 elements worth and store them into an array. So as we read 8 different elements, it just stores it into index 0 through index 7. And then in our main code, then we can access those. So I'm going to turn around then and send those values that receive data back to MakerPlot. Of course, I could use it to control the speed of a motor, or control this, or control that, or control the temperature. If I had a full system with all the I/O here, but limited I/O for examples, I just want to be able to do something with that data. So I just spit back to be plotted out. And then the same with the digital data, spit that back out to be plotted, and we're good to go. So I'll F11, download it. We'll just take a look at it, make sure it's coming in. And I did build a timeout, I think, into it. Yeah, I put a timeout in there as well. And so it doesn't get hung up. If there's a glitch, it won't get hung up and just sit there forever. It has a 1-second timeout to it or so, just in case there's a data glitch there, and we'll get data back. So that's going okay. So we'll go back to MakerPlot. We'll open up the interactive controls example and connect. Count 4, 15200 already. Connect. Okay, so we see down here transmitting and receiving. So as I adjust my sliders now, I can adjust those values and do something with it. Okay. And just for fun, I've got this oval down here that, based upon the data, it changes the axis of that, and changes the size of it and just color of it some. I think it's the last one, but just for fun, yeah, it changes the brightness of it. Just for, that's my canvas control. We can do a lot of drawing on it for various purposes and do some graphical work down there. So it's just drawing ovals based upon a radius and the angle of it and such. As far as digital data goes, we can control our switches here and be able to control our bits then, or turn them all off with a single button throw. This one's nice because it actually uses the wild card. So rocker bit anything set to 0. Reset our plots, go back again. Okay, so again, just interactive controls. We can, again, it's real easy to, slap a slider on there and then be able to give it a name and be able to read it by that name into the controller. So maybe you see possibilities for your own projects. I saw one that's coming up on I forgot what they're called already. The 3D lathe thing. I've lost the name of it right now. Sorry about that. So
CNC project.
CNC project. There you go. CNC project. So be able to control those things and be able to monitor what's going on with it. Okay, so that's all with this example. Go back to my interface selection. And next two, we'll just go back to this first one again. So let's see, that should spin. Oh, that is spin up there. For some reason, that message box gets stuck up there. That's what it is. Okay, the next one, let's go on PowerPoint first, is high-speed acquisition dump. Now, it's been about 10 years since I put Propeller, but I did some revising in MakerPlot recently where I can read down to 1 nanosecond intervals. And so I wanted a nice high speed analog signal that I could actually read and bring in and try to plot that out at very high speed. And so the P2 samples ADC and stores locally in an array at the highest rate achievable I could do. After sample completes, the average time between samples is calculated. It's converted to nanoseconds. I send to MakerPlot a dump interval to tell it I'm going to dump this data with a 350 or whatever the value is, 350 nanosecond interval. And so it'll plot that data at that interval. The array is sent as a standard, and so I send my data as a standard analog, and it uses a trigger, a little bit of trigger code to try to keep that stabilized on my screen so it doesn't bounce back and forth so much.
Well, what are you asking for? What are you asking?
Okay, so we'll download this one, F11. I'm on the right one. Okay, and it'll take a look at once in here as it runs. I'll recycle it. Oops. Did not get that one. Oh, I did click the right one. There we go. Let's look at the code real quick first. I'm sorry. But I'm going to be monitoring analog input 0 here. So I go down and wait for a trigger. And all I'm doing is monitoring the analog value, waiting for it to be rising across a certain level. So I've got my trigger level in here somewhere. Here's my trigger level. So what value I'm looking at for a trigger, wait for stabilization. There's my conversion for the math when it's time. So wait for the trigger. I get the counter at the beginning. I go through and I run through the number of samples I want. Samples is up here somewhere. Number of samples 200. So I'm going to click 200 samples because I need to define that there because I need to set my array to hold 200 samples. So to assign it up there. So we create an array with number of samples. Then I just go through and read the ADC input and store it into that array. And I found the minimum time was about 40 microsecond wait to stabilize that ADC enough. And then when it finishes, I get the count at the end. I figure out the time between the beginning and the end. I convert that to nanoseconds. Okay, and then I print it out to MakerPlot. I'm going to do a dump interval with that time. So whatever that interval time was, putting the n in there to say it's nanoseconds, and reset the plot at the same time. And then plot, I change my x-axis to be that maximum time. So whatever that maximum time was, I'm going to set that on MakerPlot so I get the full length of the plot on there, and then draw a line at the trigger level, so I can see where that trigger level was at. And then I just go through the data and I dump all that data as a single channel as analog data. Wait one second and do it all over again. So download that. We'll take a look at it here just to make sure. Enable that. Oops, there we go. So again, just checking to make sure that it comes out looking somewhat normal as far as my data goes. And now we can go back to MakerPlot and try to bring this in. Also for this interval data, I could do it manually, set the dump time up here, but I'm having Propeller send it so it can control things. So COM4, we'll do a 15200 again, connect. So there's from my function generator, I'm sending out a signal at about 1,000 hertz. And up here, I can right click this and I did too much. I can measure that, and up in the right-hand corner, it shows me. Let me change my time base here. Get rid of the hours, minutes, seconds. Just go to seconds with that. So we can measure that and see up in the corner there. I can see what the length of that is. And it says it's about 982, depending on how well I line this up. But almost 1,000 hertz. I've seen it closer before. Looks a bit far off right now. But yeah. So it just depends how we can find those peaks best. There's nothing automatic for measuring that. This red line again is my trigger level. So as we connect and replot that, and I'll play with the scope here a little bit just to prove things. So I'm trying to trigger and keep that waveform kind of steady. But my software is never meant to be an oscope, okay? So this is pushing its limits, trying to do this stuff. But we'll, oops. I'm down in kilohertz. Let me. I'm cycling this frequency up, trying to bring it up back up again. Went down to 0 on me. So as I increase that frequency, and sometimes you can see waiting for trigger. If I turn off my output, it's waiting for that trigger before it draws it. Again, just putting text on the screen. So it's using the drawing capabilities of MakerPlot just to put that on the screen so we can see it. Okay. Okay. Last example. Go back to PowerPoint here. So that was using dump, just a dump at a known interval between for that average acquisition time for all of them. The last example is data logging to flash and dump. So I'm going to log data to a micro SD card here, and then we'll dump that file to MakerPlot through the Propeller. So it stores analog data to flash for dumping to MakerPlot-J, depletes the old file first, uses time data where I'm actually going to send the time. So if the time isn't exactly the same, that's okay, because I'm going to tell it with this first value here what the time was from the previous sample. So at 3 milliseconds, plot this. And the next one could be 5 milliseconds, plot this, or 2 seconds, or 5 seconds, or whatever that time is since the last sample. And you go back in time if you want to be negative. If there's some reason to, I don't know, go backwards in time, you could plot actually negative time and go backwards in time. And this I put into the code over the weekend just to support this project. So this is a new feature for MakerPlot. Then I'm using a separate program to read the data file and send it to MakerPlot-J. Flash on file cannot be read directly by Windows. I was kind of hoping just to put that flash card in my PC, open up that file and import it into MakerPlot, but the file is not compatible with PCs and reading it. So you have to go through Propeller to dump it. So let's look at that file once. Just Zoom thing never gets my way. Okay. So with this example here, okay. Again, you know, a big thanks to all the code library out there, except especially John McFallon, who's a code I've used for a lot of this stuff, adapted things from his examples. So we set up, do our wait, we mount the flash drive. I'm going to delete the old file name. Up here, I've got a file, we'll call it prop demo, give it a file name. So if that exists, we'll delete it. We'll just say we're saving our data out to the out to serial. Open for append. So I'm going to open up this file. I'm going to write all my data, and then I'm going to close it when I'm done. So I open using a file name. I'm going to repeat it 250 times. And you can do as many as you want, as many as that SD card holds, so 32 gig or whatever it is. But we'll do 250 for our demo so it doesn't take too long. We get our beginning time here. Okay, so that's time in seconds. Okay, so I'm getting time from the Propeller in seconds, which I think is good for like 48 hours or something. Analog, read our analog value. I'm just doing a separate data thing here just for 2 channels. We're going to take that value of time, convert it to a decimal value, and then send it out to MakerPlot and append an M to it for milliseconds. Send a comma out to the file, and then take our analog value, convert it to a string, send it out with a comma, do all my data too. And convert that, and then send that out to the file, do carriage return to the file, wait 20 milliseconds, and repeat that process 250 times, writing out to the file. And then I close the, save complete, close the file up. I had this data dump where you could just dump it directly back. We'll leave that out and look at it differently. And then repeat just to keep that cog alive. So otherwise my file would be corrupted because not everything would get written to it. So let's try this once. And a lot of this, the function, the objects down here are adapted from work by John, and of course, off the chips, drivers and such. So let's bring it down once. We'll do it F12 and just look at this once and see what it has coming up. Okay. Opening file for pen, saving complete. So it wrote out to it. Okay, so we wrote that file. Okay, I'm going to go over to flash dump once, where I'm just going to then, with flash dump, I just go through. We'll give the same name. We do a copy and paste, so I'll mess things up here. Copy and paste over here, the same name. Okay, so here we just go through and we're gonna mount it and then do a message and type out that file, and then it'll be done. Say all done with it. So if it should work, we'll F11 it and open up the terminal and just make sure. And there's all our data just dumped out. So we're going to do that same thing from MakerPlot. I've got this program running, so MakerPlot connects to it. It will then actuate this, reset the propeller, and dump that data to it. So let's go back to MakerPlot. Let's reset this. Everything goes right. You should see it. Okay, got a little big there. We can bring that back down and scroll it over. And at the sample rate, it's pretty bad. We'll try it one more time at a slower sample rate. At a slower signal, right? Because I'm only sampling every, very slowly here. I cranked up this bit really high. Oops, I'll put off. Sorry about that. We'll bring it down to about 1 hertz instead and retry that. Disconnect here. Let's go back and reacquire once. So flash store, F11. Then we'll upload our dump file. Back to MakerPlot. Try this one more time. Reconnect. Oops. Didn't get it. I don't think I left this one up long enough to run. Give it a few seconds to finish its job before I switch over. I was just too quick for it. Try some more time. Not get anything. Dadgummed. I did download something, right? Try it one more time. Let go. Enter the board. Okay. I'm just going to check and make sure that file is there. So there's John's once. 2, take a look at this. Knob it up. LS. Prop demos there. We'll do a type. Prop demo. And it's there. Okay. I'll try dumping again. F11. Here is going so well, not many problems. Right baud rate. We saw it once, so baud rate should be good. There it is. Okay, let's crunch that back down again. And there it is again with that sampling. If I get in there and look at a sample, again, it should be that very small amount of time for that sample time on it. But no, I'm sorry, this is a longer one. So again, our time between samples was 20 milliseconds. So MakerPlot should have plotted with 20 millisecond sampling by telling it that. So I could get down to 1 sample's worth and identify one. It should be a time of 20 milliseconds between a single sample there. Okay. So that's MakerPlot, my demonstrations with the propeller. Thank you for your attention.
Hey, Marty.
Yeah.
That looks really good. Do you think, I didn't catch from your presentation, but can you use this to build kind of hardened, like human machine interfaces that can not have to like, they can automatically connect and do things so that the user in the end of the machine, like this would be good for industrial machinery, but it needs to be such that there's no like button to connect. It just will automatically connect and start doing its thing so that it kind of keeps things, you know, just mission based for the application.
I'm still missing the point of it. I mean, we can put a control on the screen. We can have the controller read it and respond to it. But yeah, as far as it still has to be in code, has to be written. I really haven't done anything with Modbus or anything else to bus our data together. I'm a kid's in point of your question, Chip, or?
Yeah, well, my audio is kind of messed up here, so everything sounds muddled. So I don't know if I'm being heard or if I can hear you fully, but I'm just thinking like Doug here in our shop, he builds a lot of industrial machinery, right? Where he has to ultimately coordinate things onto some, say, touchscreen display that controls the machine.
Mm-hmm.
So what you have could be used to totally generate the user interface.
Right.
But in order to make it like industrial hard, it would have to like just be able to connect automatically and not give anybody all these like little tiny, you know, backdoor configuration things, but just make like a solid, simple interface that just runs. And then it would work for his kind of applications, because his customers don't care about, is the serial connected, what port is it on? They just want the thing to work when they turn the machine on.
Sure. And you can set up MakerPlot so when it boots up, it automatically loads a specified interface. And so once you build and save that interface, you open MakerPlot, it opens that interface for you, and you're good to go. You know, and as far as the port goes, that always varies, but you need to make sure you're on the right COM port. But other than that, I do need to build in a way to disable all that editing and things so people can't go in there and mess with things.
Right. Yeah. Because in the end, a machine builder just wants, of course, the customer to operate the machine and make it do its things, but without getting into any kind of trouble or out into the weeds.
Right. Right. And yeah, I mean, someone would have to design the interface for them. I teach PLCs for industrial control systems. But yeah, but you need a designer to design the interface to coordinate with the hardware. And once that's all done, then you have just an interface for the end user to use, and that's all they have to worry about.
Yes. Yeah, because right now I see him building things like he'll get a touch screen with some controls, and he can kind of maybe drag and drop like an interface into arrangement and then use it. But it's all the suppliers for this stuff are always tenuous. You know, like he has people coming to him who have these kinds of interfaces on machines, and they can't get the old touch screen they used to get, or something changed and it doesn't work right. But if you have something that could just, you say it runs on Java, right? So it could run on a little, like it could probably run on a Raspberry Pi.
Yeah, well, it just depends on, you know, how much of Java that supports. You know, if it supports, you know, all the libraries are needed and everything for that.
But it could run on a PC anyway, right?
Yeah, just a touchscreen PC, you know, just monitor type, you know, PC.
Yeah.
You could run that.
Because this would be like kind of a nice one-stop interface. Because right now, I think these machine integrators have to hobble together a bunch of stuff, and a lot of it's like the supply chain is not really that reliable for it.
Mm-hmm. Right. So it opens up a different avenue of, you know, HMI control. There is, you know, probably there is some error as far as error checking data and things like that become more important. So with redundant data or something like that, just verify that we're getting good control bits all the time. That is one. I did put redundancy in there. I went looking for their day and couldn't find it, but I'm sure it's in there somewhere. but you can have redundant data both ways. Just to trouble check with that. But yeah, I've actually have companies that use the old MakerPlot, and they've run some systems off MakerPlot. I got started with Oakland, the National Laboratories down in Texas that does all radiation stuff. But they contacted me, and I made some changes for them and such. I did some work for Xilinx. Helped them make an interface for some of their demonstrations they were doing with their processors and such. So yeah, there's quite a few companies I've worked with out there to make HMIs with them to run their little processes and such. It's a very cheap solution for them.
Oh yeah. Yeah, if it could just be foolproof so that someone without technical information can be put on the machine and told, to monitor it and deal with it, then that's valuable. Well, it's all valuable, but that has like special value.
Right. I see a lot of hobbyists use for this, but there's definitely some industrial use. My main competitor is LabVIEW, really. So that's a niche I'm trying to cut into. Again, mine isn't quite as robust as LabVIEW is, but
you wrote the code so we could use it with the Propeller. So you have examples, which is really nice. And are those examples on your website?
They're actually in the installer right now.
Oh.
So again, if you download MakerPlot, you go to folders, microcode. All the examples I just went through are right there in the installation. So you can just hook up your P2, download those, and you're good to play and start modifying things.
Super awesome. Any more questions for Marty here? He's on our forums too, and if I see you post comments in the forums, I'll alert him if he doesn't see them.
Okay. Well, thank you.
Super good, Marty. Thank you.
Thanks, Marty.
Thanks, Chip.
Yeah, very nice.
Okay. Moving on. If Nick Benezan is with us, and he's in German time zone. Oh, good. He's awake. Thanks for staying up late for us.
So, yes, hello, everybody. Welcome to my workshop. Today, I'd like to show you my latest project. It's far from completed, but I can show some little things today. Before we get into the details, I just want to show some of the history and some theory of CNC machines. So
Nicholas, are you man at work on the forum?
Yes, exactly.
Okay.
So I'm trouble to share my screen. One moment, please. Yes.
And Nick has been here before sharing his CNC work. It was a while ago. I think a couple of years ago. He has a project on our projects page on the Propeller site with CNC.
Somehow the screen sharing doesn't work. Okay.
You do see the green button anywhere?
Mine was at the very bottom of the screen.
There we go. I've also posted into chat Nick's other project we featured, which is his stepper controller.
So, can you see my screen?
Yep.
Yes.
So, yes, I hope everybody knows what a CNC machine is. Here's my own machine. I also showed it in the forum some time ago. Like every CNC machine, it has a spindle motor which spins a cutter and some servo motors for the positioning. And obviously, there are also some propellers involved. They are in this blue cabinet behind the monitor and the PC. And let's see how all this works. The PC serves as a graphical user interface because it has the best power to money ratio, and yes, it has a decent screen with high resolution, lots of memory, file storage, and everything else. So it's better to use the PC as front end. And but the PC is not quite good at generating real-time systems for machine control. So for this, I made a couple of different PCBs with a propeller on it. And for example, this one has a Ethernet connection to the PC, and then a couple of other connectors for all the input and output signals. And these connections are for the motor drivers that can be either servo drivers or stepper motor drivers. And for example, this machine has big servo motors that drive the ball spindles. This is my own machine, so I could choose what I like to drive the motors, but in reality, not everyone has the money for such big machines. So I have some customers that sells mainly smaller machines like these desktop engravers or smaller to medium-sized routers to make woodworks, plastics, or light metal machining. And around 10 years ago, the cheaper machines all ran on stepper motors. And one of my customers asked me if I could make a complete CNC machine controller in one single box. This is to make it easier to manufacture and cheaper because all the work is here quite expensive. So even if you can get stepper motor drivers from China for very little money, you have to spend a lot of money for the putting it all together. So I designed this controller around 2012. It was quite successive. Sold over 5,000 units in the last 10 years. Here you can see it contains 2 Propeller 1s. And because I ran out of I/O pins, I also added 2 PLDs from Altera. because it was designed 10 years ago, it still had a parallel port at the back, so a printer port. And in the past, some people used, for example, Mach 3 as a controller software. And later, about 5 years ago, we added another board externally, which has an Ethernet connection and could be connected to this box, which controls the motor. And this is basically an Ethernet to parallel port converter. And there's another Propeller 1 on it. And this box has 2 relays for controlling, for example, the spindle motor or coolant. And the disadvantages of this was if you wanted to use a high frequency spindle, you had to add an external variable frequency drive or VFD. So now I move to the next step, and I'm doing a redesign with a Propeller 2. The first motivation for this was to replace obsolete chips. Well, now they are still not available, but they're getting more expensive. So I thought it was better to start now, because before they are actually obsolete. The next reason to do the redesign is 10 years ago, almost all cheap routers used that spindle motors that I will call a better power drill. They had a brushed motor and they were very, very loud. You always had to wear ear protections, and now we have better spindle motors that use brushless motors. But the problem with this is you always need an extra variable frequency drive. And although it's quite cheap if you buy it in China, the customers have problems connecting it, and you have to tune the parameters, and it causes a lot of trouble. So I think it's a good idea to build that into the controller, and the Propeller 2 enables me to control this all with one single microprocessor. And of course, it's always good if you have some more memory for future software improvements, because the Propeller 1 design was really tight on memory. And of course, last but not least, one of the reasons it's just fun. I think it wouldn't be impossible to do this with a different microprocessor, but it would be a lot of more work and much less fun. So what were the requirements? Like the old controller, it should run up to 5 stepper motors. As I said, I wanted to integrate the VFD. And of course, I need some digital IOs for relays, pneumatic valves, and sensors, home switches, and so on. Another important feature is what's called a safety circuit. Every CNC machine needs some way to stop it in the case of an emergency, and by law, it's kind of required that you install some safety doors, so the operator cannot grab into the working room for the problem with the old controller was that it couldn't be practically used with safety doors, because when you have to do a safe stop, it cuts all the power to the motors. So in theory, when you close the door again, all the motors lose their position and you have to do a homing procedure again. So that was very inconvenient, and the new controller is designed in a way so I can keep the motors powered while the doors are open, but at a reduced level so they can't move fast. So how is everything connected? As we can see, this is the block schematic. I needed a real lot of I/O pins, although the Propeller 2 has an abundance of I/O pins, 64 altogether. I actually ran out of them and needed to add some shift registers for the less time critical I/Os. Yes, we have several serial ports, one to the flash ROM where the program is decided, and one for the shift registers for the digital I/Os, and all the 5 stepper motors share one SPI bus for configuration to do all the tuning for the motor parameters. And then each stepper motor driver have their own step-in direction signals. Then we have on the other side some analog inputs. We have a I2C bus for the display, and the MIC from where the network address for the Ethernet is stored. The VFD itself needs some PWM signals and outputs the analog signals from the current sensors. We have the safety signals, which needs also a couple of I/O pins. We have an encoder input and another PWM for the speed controlled fan. One amazing feature of the P2 is that it can virtually bitbang almost any serial protocol. And here in my project, I use the P2 to generate signals for the Ethernet connection. And it does it in real time by almost bitbanging. Okay, it uses the shift registers of the smart pins. But here on the PCB, I don't use an external controller that does all the Ethernet protocol, but only a physical connection chip, and that is directly connected to the RJ45 jack with the magnetics in it.
Wow, and you're getting 100 megabit performance?
Yes, it's 100 megabit.
Wow. So at what rate are you actually shifting bits out?
It's 2 times 50 megabit.
Okay, so you have like 2 channels of 50 megabits per second?
Yes, and
So 2 twisted pairs then?
yes, exactly. And I don't know what was there's a special assembler instruction for shuffling the bits, the even and odd bits.
So you can do the Manchester encoding, right? It's called it's split or something.
Yes, it's called split.
There you go.
Yes, exactly. That's a very amazing feature of the P2. And I used 2 cogs for the Ethernet connection, one for receiving and one for transmitting. But it could run full duplex 100 megabit.
Wow, man, I didn't know that was possible. I haven't learned about Ethernet. I started to a few times, but it seemed complicated. Now I'm doing USB, which is even worse. But you know, the code that you wrote for that has a lot of value because that could enable people to add Ethernet to their projects.
Yes, there's a thread in the forum. I did it about 2 years ago, and at that time there was not much feedback. I sold a few of the accessory boards I made, but I don't know if it's true, but yes, there was very little interest at the time.
Yeah,
Is there a TCP/IP stack that you have with that, or is it just UDP?
No, not even that. My controller uses just the raw low-level protocol. I don't use TCP/IP. I think one forum member started developing an IP stack, but I don't know the current status.
That's super cool.
Yeah, yeah. Terry uses Ethernet on his light controller.
Yes.
So you're using just the raw data exchange, but you haven't implemented like the larger TCP/IP stack?
No, I don't use TCP/IP at all for this controller.
So you're just using it as a data connector, data connection.
Yes, yeah.
But then what are you talking to? Because doesn't anything you talk to want to see the whole stack, or can you just use Ethernet as just a simple connection? Because I think you'd have to have some other custom thing on the other end, right?
Yes, I only talk to my own boards and to the PC.
Okay.
I use something called it's a library for Wireshark. I think it's called PCAP or something. And you can use it on the PC to send and receive raw packets on the Ethernet.
So you wouldn't be able to route those through a router or a switch. You'd have to have a direct connection.
You can route it through a switch, but not to the internet via some sort of modem or something.
Do you estimate the complexity would be very high to implement the full TCP/IP?
No, I don't think it's too complicated. I don't know.
I think doing the raw packet seems more complicated than just putting a UDP header on the thing. Like the UDP header, I'm pretty sure it's like tiny, and you can just send it with more usual APIs.
What is UDP?
It's the user datagram protocol, which is basically just, this is an IP packet, but inside there's just whatever data. There's no connection establishment like with TCP.
Yeah, there's no connection. It just sends the data and it doesn't track. It doesn't, I don't think it does any kind of error correction. It just sends the
it does error
sends
correction. Of course it does it, but it doesn't do the sort of checking that the packet actually ends up where it should.
I think the main problem is for using UDP, you need an IP address. And I want to get rid of all that. I don't have an RLP protocol or something. I just use the MIC address.
You can just
to find
set
my
an IP
box.
address. It just, you don't have to get it from anywhere. It just needs to be. You just need to make it configurable
he would have
so
to,
it doesn't conflict.
Yeah, he'd have to advertise ARP to do that, but that's okay. I mean, it's not too much. I've seen a couple of very lightweight IP stacks available that are open source and that kind of thing. It's all C, and it's definitely beyond me to implement. But I think you could probably take this because you're just using the what is it RMII interface type thing.
Yes.
Okay, yeah, and that's I believe that's the kind of thing that these lightweight stacks will plug into. But unfortunately, C is one of those things to where I can look at snippets of code and be able to read, but whenever you get into like actually all of the things that surround C, it's beyond me because you have to have a high level of experience of just fighting with the compiler and everything else to make it go.
Yeah.
Yes, I think there's a lot of code in the internet for IP stacks in C, of course. It's probably not much work to port it to the Propeller if we use FlexSpin or Catalina. But to port it to Spin would be a little bit more work, I think.
Yeah, well, it might have to be kind of in PASM just to be able to switch things very quickly. But what you're doing is you're kind of just using it as like 100 megabit per second serial port, right?
Yeah.
That's just amazing, that level of throughput.
Well, gosh, if we only need the phi is what that connector is, right? Or it's the magnetics, the RJ45 with the magnetics, and that's talking pretty much straight to the P2 pins, right?
Yes, there's a small chip between, but it's less than $1.
And what does that chip do?
It does the Manchester encoding and the outer net negotiation for the connection.
Okay, so you're able to send just digital data to that chip, and then it generates the final signals that are strong enough to drive the interface.
Yes, exactly.
Yeah, because those have to actually be sinusoidal signals, right?
Yeah.
And they have like it's like, what do they call it? Like a token constellation where they shape, is it like a 25 megahertz waveform or something? And then they can extract like 4 bits per cycle. Does anybody know?
Yes, I think the encoding it encodes 5 bits for 4 bits in the data stream, so it's actually 125 megabits.
Oh, okay.
So it's actually not Manchester encoding, but like the old hard drive used RLL encoding, run length limited. I think there's something in the data sheet of the MIC chip.
Okay. Hey, could you tell me what the part number is? Because I want to look up that part, that $1 part. Do you remember?
Yes, one moment. I can look it up. So here's
Yeah.
the schematic. And if we zoom right in.
So it's the LAN 8720, LAN 870.
Yes, exactly.
And that, okay, so there's TX and RX that are digital. Then it has a 25 megahertz crystal.
Yes.
Cool. Okay, well, I'm gonna read about that because that's pretty neat. Gosh, if we could have an object that could, you know, run 100 base or whatever they call it, that would be really neat.
Yeah, and it's really trivial if you have Ethernet connection on the LAN to communicate to any standard, you know, TCP IP socket server software.
Yeah.
And just putting in the little bit of proxy that rewraps the Ethernet frames and directs them to a particular socket is a trivial operation. So you would have networked applications without having to worry about any TCP IP stack implementation on the Propeller side, which I think is a beautiful thing.
Yes. Yeah. So to run that much function, do you have to like buffer packets that don't belong to you and pass them on to someone else? You have those kinds of responsibilities?
No, I mean you would simply be selecting a particular I forget what the channelization parameter is in the Ethernet frame, but there's a way to say I want everything that I hear on the Ethernet that applies to this particular channel or application or whatever it is, and wrap it in a TCP IP header and forward it to some TCP IP server, and then they'll communicate bidirectionally. So the overhead is just like a proxying application on the server side. But you know, this is LAN functionality. You're not going to go over a wide area network doing this, not without some other components at least.
I see. So you're kind of out of the mainstream of the data. You're just asking the LAN to give you certain things of interest.
Right, right. So you've got a proxy application that's basically watching all the Ethernet frames and selectively picking out the ones that you want, and then forward it into a particular server at a particular, you know, TCP IP address and port number.
And is that a very common thing to have working? And is it just a matter of software on a server?
Yeah, well, the canonical solution would be to use a program called SOCAT, which is just a Unix command line interface program that's been around for decades. So SOCAT is like socket cat, right? So it's like, you know, take input from some physical interface and then forward it to some other physical interface, and it can easily do Ethernet to a generic socket interface. So I would say if you want something else to read up about, look at SOCAT on Linux or any other flavor of Unix. SOCAT.
Okay, SOCAT. All right. Now, question though, if you just have, can you have the P2 just look at, because if you have a dedicated POG, it may not matter. Could you just look at every single packet coming through and then like select out ones that are of interest to you so that you don't need anything special going on upstream?
You don't need anything special going on upstream. That's the point. So the Propeller can do what I think it's currently doing in this application, and end up communicating with, you know, just a generic piece of server software.
Wow, I need to learn about that. I don't even know what I don't know about that, but that's really interesting.
Well, just by way of a little more information, I mean, SOCAT is the application I use on the Raspberry Pi to take my 1.5 megabits async input coming from the Propeller 1 in this case, and forward all that information to a socket server. So it takes an asynchronous, serial stream, 1.5 megabits, packetizes it and forwards it to a TCP/IP socket server using SOCAT. This is the exact same application as that, but using Ethernet as the input instead of a asynchronous serial port.
Okay.
So yeah, I mean, if you have any, I mean, bring it up on the forum or email me or whatever if you want to. I can talk more about what I did with the P1. That's very similar to this.
Okay. Because I know it, like Doug here, who builds all these industrial machines, they use Ethernet and 100 megabit Ethernet among all the machines to communicate. Like the PLCs use it, the cameras use it. Everything is talking on this 100 megabit stuff.
Right, right. And if the P2 can keep up with that, once you relieve it of the overhead of TCP/IP, then yeah, that's a great way to interface, within a building or whatever. And then you could have other solutions if you needed to go building to building or something.
I see.
A forwarding. You need a forwarding proxy too, right? Instead of like a local SOCAT that's talking to a local server, you need a local SOCAT that forwards to a remote server. But then you've got the P2 talking Ethernet to something on the LAN that then forwards all the information to the cloud or anywhere across the internet. But you've got lots of bandwidth between the P2 and that local proxy, right? So you can go as you'd be limited by the farther downstream bandwidth considerations, I think.
Yeah. Like what Martin was showing us. I mean, what if you just had that thing driven over some kind of data link like this so that you could, translocate the machine interface to anywhere, and this might be important for that.
Yeah, it's that plus the fact that Cat5 wiring is almost ubiquitous.
Oh yeah, yeah,
yeah. I should let Nick finish up his presentation.
Yeah, I know. I don't mean it.
Yeah,
I agree. I agree.
Interesting sidebar. Sorry to take up the time.
Yeah.
Thanks, Nick. You can continue.
Okay, I go to the next page. This is the last piece that was visible on the previous picture of the PCB. This is the VFD driver for the spindle motor. And this is basically very simple. It's just a rectifier, a DC bus, and 6 transistors, and 3 current sensors. Of course,
are those current you said Hall effect, does that mean they are giving you that gray pattern? Are they digital or are they analog, those Hall effect sensors?
They are analog.
Okay, so you're doing some kind of field-oriented control then?
Yes, kind of. I showed it in a couple of minutes. So the advantage of the sensor is that they are isolated, so I can monitor the true currents to the motor coils at all the time. I'm not using shunt resistors in the lower leg of the transistors, because if I use shunt resistors, I could measure the current only when the transistors are turned on. And the Hall sensors in this connection, I could use the ADCs of the P2 with quite a lot of resolution.
Well, yeah, so having those analog sensors isolated is great because you get real-time feedback without interrupting the circuit or having to put it into another mode, like where you're not driving it.
Yes, exactly.
And the Hall effect sensors, are they detecting like magnetic field, or are they just measuring current?
I think there's a small loop inside the housing of the chip. It's just one winding, and there are two Hall effect sensors, one for the forward side of the loop and one for the backward. So they subtract the signals to get the current.
Okay.
And all external fields are cancelled out. So if you have a static magnetic field, both sensors sense the same signal, and as you only see the difference of both external fields, don't interfere with the sensors.
Wow, so you're actually using those to monitor the current in each leg of the motor continuously.
Yes, exactly. And I do what is called a Park transformation. One transformation generates the rotating vector of the three sine waves. And the backward transformation transforms the rotating current vector back into the rotor reference system. So I can show that if I run my application.
That's really neat, because so what you've got there, you've got floating sensors that sense the current, but without having to reference to ground or anything. So that, because when we made our motor control board, it's too bad Michael got off the call, because we went around and around with all this stuff. But this is much more elegant because it runs continuously without any interruption.
Yes, exactly. It has one drawback. Of course, it's a little bit more expensive than just a sense resistor.
Is it that much more expensive?
Depends on the accuracy you want. If you want really low noise, high quality sensors, then one is around $5 or $6, $7. The ones I use, I think between $1 and $2 per piece.
That's not bad.
It's probably too much for little brushless motor for a robot, but for an industrial control, it's worth the money, I think.
Oh yeah, yeah.
So I have a question. Is this just for the control of the motor, or could you be able to detect torque, like the load, like on some of the higher end CNCs? I see that they show how much load the spindle is under when they're cutting different materials. Or is this just to control the motor's speed?
I can sense the load. It's probably not good enough for a really high resolution servo motor, but it's definitely enough to control the speed very precisely.
Yeah, you can, but do you also have like an optical or some kind of encoder on the motor as well?
No, I don't have an encoder on the
Okay,
spindle motor.
so
yes, I could connect an encoder, but it's not for positioning control. I plan to add that later to control a lathe, so I can cut threads. But in this case, the spindle motor just turns the spindle at a defined speed, and the servo motor of the Z-axis just follows it to cut the thread. Maybe I just continue and run my application software, so I can show a little bit how the current sensors work.
That sounds good. And Chip, I've passed host to you because I have a 3 o'clock meeting.
okay.
So keep Nicholas supported, so he can finish at some point. when you guys
Yeah.
are done, because he's in Germany. And
Okay, was there anything else on the schedule today?
yeah, there are two more things. Stephen Morraco knows.
Okay,
And
so
then yeah, so Stephen, and then your USB, and you guys can
okay,
goes and
okay,
show
good.
it. I'll loop back when my other meeting's done.
All right.
Okay. Vielen Dank, Nicholas.
You're welcome. So I don't know. You can see my main screen with the
Yeah.
VS Code, and here we have the controller and the spindle motor. So I just press.
Oh, no, you're using a vector
compiles.
scope.
So okay. And now, as I load the motor, you can see the points moving a bit. Maybe I have to run it a bit longer.
Yeah.
Yes, this is one of my problems. You always have to close the terminal windows.
You're using Stephen Morraco's VS Code setup.
Yes. Sometimes it doesn't find the P2. I don't know why.
There's most certainly a way to make it reuse
yes, okay.
the terminals for the same task anyways.
Yes.
I have to close the peanut window. Okay.
What's that called?
Now, if I load the motors, the point shift to the right, and this is idle, and on the load.
It looks like there's 5 points there.
Yes, this little rotation here is caused by some, I think, by asymmetry in the motor winding. So as the rotor moves relatively to the stator, the poles of the motor have different inductivity, so the current changes a little bit, and this is what you see with the little circle here. So what it actually should display is the D current in the vertical direction and the Q current in the horizontal direction. So as the current goes up, it moves upward in the vertical direction, and as I load the motor, the points move to the right in the Q direction. As I said earlier, the software is far from completed. I need at least 1 or 2 months to complete the sensing of the load of the motor and the feedback to boost the voltage and to compensate the slip, so the speed stays constant. But as we can see it now, it's a proof of concept, sort of.
Yeah, that looks great.
So maybe I can also run. I have to switch to Propeller tool now, because FlexSpin doesn't support feedback from the mouse at the moment for debugging.
Oh, so you're using
I think it does now, at least on the code generator side.
Really? A few days ago it didn't, yes.
Yeah, but Eric just sort of patched it in, I think, at some point.
Okay, that's
I
really
am
nice,
weird.
yes.
I hit F5 on the commit list on the spin to CPP repository. And that's how I know these things.
Okay.
Yes, but you have to build, it's the source code in spin to CPP. It isn't in a release yet.
So I just run that one, and now we have a small terminal window, and the mouse position in this window is fed back to the propeller. So it it runs a small stepper motor. My camera has some problems with the focus. I'll put that here. So when I move the cursor in the terminal window, the motor spins up. Down and here at the top, this is the step frequency, the readout of the status register of the dynamic chip, and V is the time between two steps measured by the dynamic chip.
I'm trying, let's see. I forgot how I did the mouse thing. I have some, let's see. Here we go, PC mouse, okay. Okay, so the mouse thing, I had forgotten, but it returns wherever you are in whatever window you're in, right?
Yes, exactly. You can connect it to one of the debug windows.
Yeah.
This is the terminal window. So the PC mouse gets the mouse position back from the PC and stores it in 7 longs here. And XPOS is then used to calculate the frequency, and I just limited the acceleration rate here so that the motor doesn't stall if you move the mouse too quickly. Okay. That was all for the moment. Are there any questions?
I have a question. Do you think that have you run into a need for any kind of debug, like window facility that you don't already have? Like, did you wish there was some other feature that would make things easier for you?
Yes, I have. I'd like to have a single step source code debugger.
Wait.
But that's quite complicated, I know.
Wait, a single step oscilloscope debugger?
No, source code level debugger.
Oh,
so
source
that
level
you can
debugger,
step
yes.
through spin programs. I already used the assembler level debugger. It's good for finding false jumps or misuse of the flex or whatever such typical assembler bugs. But it would be really useful to have that at the spin level, so you can single step.
Oh, okay. So you want a single step spin code? That's right.
Yes.
Yeah, you know, when I made the chip, I didn't realize that I should have had a like debug interrupt on bytecode. I didn't do that. I only have it so you can have like an execution address you can stop at, or you can single step. But I should have made it so that you can execute on every bytecode or a particular bytecode, and then that would have really facilitated Spin2 debugging. But all we have now are just snippets of PASM code running that make up the bytes, and there's no way to like know that an X byte just occurred.
Yeah, that's a thing, right?
Yeah.
With all the funny CPU simulations that I've done, I've actually never used the X byte because I always have to do stuff in between, like checking is there a virtual interrupt that I have to handle or something like that.
Yeah.
So I always just use execf from a table.
It would have been so easy to put that in the chip. It would have been a couple of gates, but it just didn't occur to me.
Yeah, it happens. It happens.
Yeah.
Yes, and
you have it in the 1 megabyte version.
Well, that looks great, Nicholas. Thanks for sharing all that. All right, well, Michael, you want to go? I mean, Stephen. Oh, you're muted.
Of course I'm muted when I'm trying to talk to everybody. Why? Why, I ask you why. Okay, let's see what this does. Hopefully that's my desktop.
Yes.
Good, okay. I am running the latest extension that runs the VS Code using a language server built into the extension. And what I want to show you today is the current status of things. So I'm going to operate under the pretense that I'm just starting a new project. And the way I'm going to do this is copy some files into it. And then let's see where I am. Good. Let's start up VS Code. I have a lot of stuff here. And so here you see the file I just copied in. And what we're going to see is the performance. Let me get things out from under my controls so I can run them. Okay. So here's how fast the thing is parsing. And you see all these?
Not seeing anything yet.
What are you not seeing?
It says you've started screen sharing and it's just spinning.
I'm seeing the share.
Anybody else
see the
VS
okay.
Code?
It's just me then.
I see the VS Code screen.
Yes,
okay.
Me too.
It's very small, but I can see it.
The font is small? Is that what you're saying? Or is the screen small?
Well, everything's small.
Okay, because I have a large screen shared. Sorry about that.
You could share a portion of your screen and it would not show all the extra stuff. If you don't need
I'm actually needing the extra stuff for the demo here for a minute.
Okay.
So I'll make it quick, but the key is that we are reading, we have declared objects up here. And as I've loaded the file, I've run semantic parsing against it. And if I see semantic parse errors, I register those errors back to the client. And the client has CodeLens installed. And so it's taking these errors and putting them on the individual line where they, you see this format not found error. It's actually putting them on lines of code where it found errors. And so the reason is because these files, I'm not getting a files don't exist message. That's interesting. The next thing I'm going to do is bring over the utilities into the project, and you notice those errors went away.
Because shouldn't that error be in the object import if there's no object like that? That seems very unhelpful, putting an error on every usage of the object if the object is missing.
It will also be on the object is missing too. I'm surprised it's not showing up there.
Yes,
And
but that's a sort of this noise. It's something I always hate when I'm using like a C compiler and I forget like one semicolon at the top somewhere, then the entire rest of the file just
well, let me
prints
go
1,000
on with
errors.
it. Yeah, Ada, go ahead and submit those kind of things to me. Right now, what I have is a number of errors.
Yeah, sorry, I always start.
Right? So go ahead and submit those, but let's go on with the presentation. And so right now you see that the server was notified that a new file arrived in the folder and it reparsed the files you have open. And so it's reducing the messages. Continuing then is another file that's missing. And so now all of them went away because I brought in those files. What we don't see, because I need to do one more call, this utility should have turned red because these methods are still missing. That's because when I release this code, I have the code set up without the test variables, the test methods enabled. And so I come back over here and I will uncomment the test methods, and you see live, the files had all of a sudden all the methods appeared. And so what we have here is live active parsing of the files as you're editing them. So if you have two open and you're adding new constants in a file, they'll show up in the file that's trying to use the new constants. You're adding new method calls, they're going to show up in there. Also, the things that are new is the documentation actually comes over from that remote file. And so here's the documentation in Flash. You'll see that I have open to the side now. I have documentation in here for various things. And let's find open. Hello, open, outline. And we have object dependencies, there aren't any. We go to open and you see what the documentation looks like here. And it is now the same documentation over here. So every file that is referenced in your object list is parsed as the file is opened, and all the symbols are gathered, comments and everything that are needed to present in the interface, not all comments. And they are stored in a symbol cache, if you will, for each file. And now as you access things, it tells you about what they are. And so this is all live and active and hot. So as you're editing files, we are now in a position with this mechanism that we can add code completions and suggestions for as you're typing. You'll see also I have two opens in here for a reason. Right here. This is also live when we're doing suggestions. So as you're typing the signature, it's telling you which parameter you're typing. And then it gives you the documentation for that parameter as well. And so now as you type it in, and you notice test file doesn't exist, but I can move on. And now it's saying, what mode do you want? And so this just tells me the symbol doesn't exist yet. Missing declaration. So that is the new state of things. With respect to this, I should be able to, I have yet to do final testing on the colorizing and tabbing and stuff like this, making sure it's all back operational again. But right now, all of this is working on P1 and P2. The error reporting is live. And so now I can go back here and share this a little bit differently. If I can find where I left it just now. There we are. Now you have just the code. And let's go out here then. And look at some other code. With this very rapid file parsing that we have, it's amazing to go back and look at older code because things like this happen in it. And it's like, you know, how do I have code here that is already broken? And it turns out that that is strictly because we have variables overriding variables, and I'm actually catching them in the code. No errors here. You'll see in the right-hand margin of the window. Can I make this smaller so there's less shared? Does that help everybody? When there are errors,
Yep.
you'll see down here the red in the bar. And so we can scroll down there real quick and find out what the errors are. And basically this is because we forgot something like these.
That is slick.
So
Yeah. Does the documentation do anything with the PASM code?
What do you mean, does the documentation do any?
Do you see any type of pop-up documentation for PASM recognized, keywords, mnemonics?
Oh,
PASM mnemonics, I mean.
You mean things like this? Yes, absolutely. Right now it's spin code. There's absolutely no reason why it will not be all the PASM mnemonics as well soon. That's a lot of data entry for me, but I'll get there.
Well, that would be, I mean, it's so helpful though when you're learning something like PASM 2.
Yes, exactly.
So helpful.
So it'll be there. Right now, if you hover over things like this, it's all there already. All the smart pin configuration variables are all there. The setups and things like that. And so that's the kind of thing that's going to be really helpful. Also, you'll see things like this. Where was it defined? It'll actually call out the declaration line. I don't do interpretation, but I do at least give you the source line. If it's from another file, it'll be telling you it's found in that object, obviously. What other things? There are errors in here. What did we do here?
All those errors that you have, those are just annotations, right? Those are not actually changing your code. They're just markers or annotations.
Correct. When I process the file, I generate a list of errors found, and I return that list from the server to the client. And the client then, if it's running CodeLens, will take those and put them out here. If they're not out here, let me show you this. If you don't have CodeLens running, instead you have a list like this, which is navigable. You have both in both cases. But now you can go out.
8.4 miles?
Say again. What are you reading? I'm not with you. What? So anyway, this is all live, and as you fix them, that's telling me in-string is not here. Is that possible? Yes, it is not. It is possible. And why is that error missing? You can see I'm still in testing and still trying to fix things. Normally what happens is when this file is not found, you'll get an error out here that says unable, couldn't find that object. And so this leads us to a couple of different things. As I'm wandering around the old P1 OBEX, trying to certify code, I find errors like this in the code. There was apparently maybe we had a pin C instruction at some time that we no longer have. And so there is an object or two out there that use pin C that doesn't exist. And so that's flagged. There are objects out there that were released without all of the included files. And so you get then on the includes in the object lines, you'll get, I can't find this file. And then of course, everything in the file is highlighted and things like this. So my point though is that I guess a couple key points are you can see how fast this parsing is now. It'll be interesting to see on much larger files. Ada, I'll expect feedback from you when I finally get a version to you.
Yes, it will probably implode like the first second. Does it work with the line continuations now?
Not yet, no. I can
so
get
it will immediately explode. Okay.
Yeah, it'll immediately have lots of fun, I'm sure, with your
Does it have go to definition now?
Say again, please.
Does it have go to definition now?
Not yet.
It's like one feature that's incredibly basic and that I've been waiting on because that's actually useful.
Now we are in a position to know which files those definitions live in, and we know immediately what line number they are. So go to position is me adding, half page of code or so, and accessing data structures that already exist, and I will open the file and place you right there. or move you within the current file. So it's very feasible. Same thing with code folding.
Well, you don't even have to move you anywhere. It just asks you where it is.
Well, I'm saying the feature will be enabled very easily now because we have the language server. And that's my point, right? Is we really needed to get to a place where all of these,
what I do,
I could add these features very easily.
Want to jump inside the same file anyways.
Correct. I could jump within the same file before, but now I can jump across files. And so all of this parsing is now working across files. I am not able to release this yet, but I'm only a couple days away. Reason being is that I got to make sure the coloring is working. I got to make sure the highlighting is working. You can see that already client-side behaviors like object dependencies, that's client-side. And that's operating. Here's the missing file indication even. And outline. Outline is from the server. Object dependencies is from the client. You can see that the client has client-side behavior specific. It's my belief at this point, but I've got to turn it on and make sure it's working, that the indenter, the tabbing, and the colorizing, the prop tool coloring, that's all client-side because it's single editor behavior.
I wonder if you can, how easy it is to make the language server run with a different editor.
That's going to be up to somebody to play with. It's a standard language server interface. And so actually having it, being able to pull it out of the VisX package and hook it to another, there are instructions for how to do that. I'm focused right now on just making the capabilities work.
Because I have this funny thing here that's like the default text editor on Kubuntu. And that always complains that it can't load an LSP for something. So it appears to have some sort of level of LSP support.
Then you might be able to hook this in, which would be interesting.
Yeah, I want to see that.
Yeah. So
partially because this is like trillion times faster than VS Code at actually opening a file.
Sure, that's understood. There are going to be many different editors that do this. Okay, so any questions before I walk away from this presentation for now?
Yes, I have a question.
Okay.
Do you have the capability in Visual Studio Code to do the same things that you would in the code editor that comes with Spin and the Propeller? As far as compiling? As far as compiling the code and shipping it up to the board?
Okay, you saw Nicholas demonstrating that capability with Visual Studio.
Okay, I'm sorry, I missed it.
Yeah, he was running Flex Spin behind, and thank you, Nicholas, for showing that. He was running Flex Spin behind. He was downloading the code and running it on the devices. Nicholas, regarding the answer, I think there's a reuse parameter in your tasks file that will actually reuse the term windows. I'll point that out in the form when I come back to you.
When were you going to be done with your work on these improvements to Visual Studio Code?
I didn't finish my thought there. Thank you for asking. I'm expecting, squirrel. So I'm expecting 2 or 3 more days just to certify the functionality. If I have a couple people that are really interested in putting it through its paces and giving me early feedback, I think it's at feature parity with the current release. In fact, the syntax highlighting is even better because I've been finding other problems and fixing them in this new release. But I really would like a couple of early adopters. I'll send them a compressed install file, and they can just install it by hand using the code command line, the VS Code command line to install it. And then they could run this and give me early feedback on problems by email. I would be interested in hearing what kinds of things. Hopefully I haven't missed anything glaring, but the kinds of things I've been dealing with lately are making sure it can load UTF-16 files and UTF-8 files. That's working. Allowing whitespace and file names. That's now working. Allowing parentheses and directory names. Who knew? That's now working. So, I had to get a bunch of things working that I didn't expect, just so I could run through the P1 OBEX and the P2 OBEX
Oh,
There's
other thing, I think I've reported like a bug some of these other days.
You did, and I have that, and I commented back to you that I'll make sure that's fixed before I release this version. You said it's locking up and processing some lines.
You said that 23 minutes ago. I couldn't have known.
Yeah, exactly. That's why I'm answering you now. Thank you, Ada, always for reporting these things. The strength of our tools has to do with how well we report these findings and things.
Yeah, the strength of the tool has to do with how often it locks up the entire editor when you open a file.
Yeah, exactly. Oh my gosh, you should see me testing this thing. I've crashed the editor so many different times by accidentally pasting an entire file in a log of results into the find box. It's not happy when I do things like that.
Oh, you can crash it by pasting things in the find box?
Yeah, if you paste a 4,000 line file into a single word find box, it's kind of interesting to watch it stall.
Bizarre, because you'd think that wouldn't be any more inefficient than just typing normal stuff in, unless it's in regex mode. I guess it will try to compile the whole thing, which may not be very nice.
No, but basically with server processes, I'm running so intense with so many sub processes with a server that the whole thing will eventually just tear itself. Chip, I can't hear you. I know you're talking. If you're talking to us, we can't hear you. Okay, anybody else have any questions about the status?
A question about the language server. Does it understand yet the flex bin extensions like optional parameter initialization or?
I've gone through, I want to work with you on establishing what the set is it should extend. The first thing I have right now is a setting that turns on understanding of the define in if-def and those kind of directives.
Oh, great.
So that's already there. I want to do a little bit more live interpretation of that, because now with the syntax highlighting, I can actually like gray out regions of code that are no longer enabled by the if-defs. I actually have an ability to do something like that now. I haven't decided what the response is, but I'd love to work with you on that and see what your favorite approach might be.
C++ extension for VS Code already has like a gray out effect that it does.
Good.
For when it's not selected. I would say that's probably a good idea to match that.
If you could send me a screenshot or something like that, I'll be glad.
I just install the C++ extension and write a thing. It will not explode
then I
on
have
you.
to find code. You're making it hard on me, Ada. You're making me work.
Where's the thing?
Help me out.
I have to make these noises. That's the punishment.
Okay, fine. Anyway, thank you all for.
Where's the things in there? Oh my God.
I'm excited by the status of this. I hope you are too, and I'm excited to get it out to everybody as soon as we can.
Yes, this is very cool. Thank you.
You bet. Nicholas, one question for you. It looked like you have semantic highlighting turned off on your editor. Are you syntax only? It's a theme. If you do Command KT, I think you choose the theme, and then you'll see Iron Sheep syntax or Iron Sheep other.
I have to check, but I thought I have it enabled.
You have a lot of white text in there, which tells me semantic coloring might be off. I know because I've been chasing down and finding and fixing all the white text that shouldn't be white text. So, Chip, I still can't hear you. I'm assuming you want to present next the USB stuff.
I think he's going to throw his computer out the window in a second.
Grover,
he put in the chat, he's having issues with sound.
Okay, good. Grover, if you'll send me an email, I'll work with you by email then.
I have a picture, but how do I get the picture across?
Email it to me?
Oh, I have to find here. I have to first save it out somewhere, probably. And then I have to like find mail client. compose. Is it Stephen at Morraco or is it Stephen at Iron Sheep?
Yes, but I'll make it easier for you. The name I want, the mail that I use when I work my business is ironsheep.biz. Stephen,
Can you guys hear me?
Ironsheep.biz. Chip,
there you go. Now you're working.
Okay, well, I have another problem. I can't hear you. It's like I'm underwater or something. It's very muffled and like low pass filter. So I got to figure out how to get things straight.
Next to the microphone.
Audio randomly breaking.
Yeah. Click the little arrow next to the
Not the
microphone.
first time it happens.
You should be able to change settings there.
I dropped my email in chat in case anybody's wondering.
All right, Stephen, I couldn't hear the last part of your thing. Can you hear me right now?
I can, thank you.
Okay.
Your sound is good.
I got to get my sound back. Everything sounds like everything's underwater. I don't know what I did, but I can't hear you guys. I can only hear like mumbling.
Chip, that might be a Zoom issue. You might look into your Zoom settings to try to correct that. I've seen that before.
I still can't hear. Let me see. If I turn down the bass, someone say something.
Hello? Testing 1 2 3 1 2 3.
You know, it's like the sample rate is super low. I'm not getting any high frequencies at all.
Huh.
I don't know what happened. Let me get out of the meeting and then back into the meeting, okay?
But you're the host.
You
Won't
are
that end the meeting?
You're a host. That's going to be a problem.
Yeah.
That might do the trick here. Hold on here.
Host leaving is bad juju.
Oh, wait. I'm
I'll leave.
hosting. Hold on. I have to hand it to you,
us all out.
Stephen. Hold on.
Okay.
I wonder if the recording is blowing your is causing you bandwidth issues.
No, it's
Let's see.
recording to the cloud, so I don't know.
The
I need
cloud
to,
TM.
Okay.
This is why Ken cannot be allowed to leave early.
I know.
Old man yells at cloud.
Ken, where are you when we need you?
How do I pass meeting control to like Stephen?
That's a good question. Zoom menu, Zoom, meeting, keep on top, speaker view, mute audio.
The links in new OBEX aren't rel no follow. How interesting.
What? More website updates there then?
Well, it could be that's the intent.
I gotta pass the control to someone else so I can get out of the meeting and then back into the meeting, but I don't know.
Is it a right mouse on your account on the participants
Better
list?
type it because I just can't hear anything. Sorry about this, guys. All the stupid things that computers can do to you.
Where can you transfer?
There's a thing such as too much computer.
Really?
Yes.
I
Too
have
much
to
computer.
pass control to somebody, but I can't figure out.
Like sometimes you think you solved an issue using the computer when like the better solution that's far simpler just doesn't, it's like right there.
How do I pass control of the meeting? Participants. Let's see, if I go Stephen. Oh, here we go. Make host.
There you go.
Okay, Stephen, you're host.
Okay, I'm hosting.
I'm going to leave and I'm going to come back.
Okay, good luck. Which, by the way, let's see if this works now. Yeah, okay. I had to try. What can I say? That's a new automatic feature built into the twin thumbs up is a feature built into Zoom. It's just, I was hosting a radio club the other night and accidentally did that in our recording, so that should be fun.
Stephen, while we're waiting, I have a question.
Please.
I use Visual Studio Code to use I can't think of the name of the thing. It's an add-on to program for other microcontrollers like Teensies and things like that.
Yes.
If I install your thing, does it change that? And do I lose the ability for any other add-ons or anything I've done to code?
No. That's what's so fun about this. My extension is unique to Spin and Spin 2 files only. And so when you start editing those files, my extension kicks in. And when you close those files, my extension is completely dormant. Except for Ada may tell you that I'm failing in some of that with the tabbing, and I'm trying to clean that up.
There was another comment made by, I think you and Ada were talking earlier, and that I think she might have been alluding to the fact that the language server follows like a standard called LSP.
Yes.
And it's actually portable to other editors. Would
Yes.
that mean that your entire suite, the syntax highlighting, the parsing, the markup, the documentation, is all that going to wind up being portable to other editors?
Anything that's server side ports to other editors. Anything that's client side does not. So what you lose is the tabbing, overtype insert kind of tabbing, and what you'll lose is the object inheritance tree, and the other thing you'll lose is the colorizing, the Propeller tool colorizing. Those all stay on the client side. Everything else, the highlighting and everything else, transfers. You still have to pick up, your language server will identify what the object pieces are by name, local variable, parameter passed to method, public method, private method. They identify it by name, but then the color themes are unique to the editor. And so the color themes have to then associate colors to those names. So I believe the color theme would have to be added as well.
Yeah, that makes sense. But that's not much of a sacrifice or much work to get it working on theoretically, to get it working on another editor.
Theoretically correct. The first one to try it will be the one to tell us how hard it was.
Yeah, yeah.
That won't be me right away because I have a bunch of functions I want to put in. And I also have the ability to actually move, now that I've learned how, I have the ability to move some of the stuff back into the server in a custom way, but of course those things won't port unless you add some code to your editor to invoke the custom methods. So the colorizing I may move back into the server. The thing that parses and identifies which regions get colored as pub or pry or con, you know, that moving the data, what are the current line offsets for the regions for the current file, I'll move that back to the server side.
And is the server side implementation like a standard recognizable type of code and API, or is it something weird like JavaScript and XML or JSON or something?
Well, it's kind of a mixed answer. First of all, servers can be implemented in any language you want. I chose TypeScript.
Okay.
There are the majority of the servers out there, I believe, are TypeScript at this point.
Okay.
The difference is my parser is custom versus a tree-based or a grammar-based parser. It would have taken me much longer, in terms of, think months longer, to convert to a tree-based parser. And so I just ported my existing custom. There are, in Spin, there's a different parser essentially for each section. Con, dat, var are different parsers than what you have for pub and pry. And so I have a bunch of custom parsing that I just found easier to do that way. However, the API to the server
parsing is nightmare.
Yes. Yeah, in addition, the language itself is a little bit difficult. But going back to the API, the language server API is fixed and common across all language servers. It's JSON communication, JSON data being sent to the server, JSON responses coming back, and the editor.
Setup, isn't it right?
Say again, please.
kind of a bizarre setup that they've sort of come up with. Like we have a server process that's running on the same computer and we're passing JSON messages between them. Like that's a
I don't
bizarre
want to
level of
critique that.
indirection.
Yeah, I don't need to critique that. The point is it's a standard interface, and all language servers adhere to that interface. So if you port a language server written in whatever language to the new editor, it should recognize that it's a language server. It should recognize how to send deltas to documents to the language server, and it should respond as it's supposed to. So that's the hope. I look forward to somebody being willing to try that, and I'll work directly with them if they find any issues or need help in making sure it works.
Chip, I'm still not video was freezing, but no, he's just that astounded at the computer. Anyways, I am ready at least for USB hell.
Yeah, exactly.
Look at the box. It has all the USBs in it on frame.
Chip, are you functioning yet?
USBs. We are truly in hell.
Can Chip even hear us?
Possibly.
Hey, Stephen.
Yes, I can hear you now. Sounds good.
I don't know what is wrong with my audio. It sounds like it's applying some kind of equalization curve where it's
check the jacks.
It's all like 100 hertz and nothing else, and I can't equalize it away. But anyway, I can try
the jack. Check the jack.
Do what?
Check the jack.
I did. Jack where you're plugged in.
I unplugged and plugged it like many times.
You're on.
Everything went to pot when I tried to change my like digital sample rate inside, because everything today has been boomy. I'm not hearing like highs and mid range very well. It's all bass. So
it's intriguing.
Let me unplug and plug the microphone.
Is it a USB based mic?
Okay, well, sounds like the same.
Sounds the same.
Okay, Stephen.
The audio's good.
Did you?
Good.
You can hear me okay?
Yeah.
Okay, I mean, I can't hear you guys. It just sounds like. That's all I hear.
Thanks for the recreation.
Yeah, this is why I just. Modern computers are just so maddening. They just spring stuff on you. You never know what they're going to do. Anyway, did you get through the things you were going to talk about, Stephen? Okay. Was there anything else that we had planned before I do the USB thing? Okay. All right. So, you guys, okay, I'll share my screen now. Let's see. Okay, so this is
there we go.
Packet exchange. You can see this.
Very tiny share.
What's that?
It's a very tiny share, but we got it.
I can't
Small
understand.
portion of the screen.
Okay, you can see this thing that says USB packets, okay? Okay, all right. I'm sorry, I can't hear anything except mumbling. Okay, so this is at the root what goes on with USB is there's this packet exchange where you have like bus states normally idle. Then you have what's called a sync, which is like 6 rapid transitions followed by 2 steady states, or 7 rapid transitions in a steady state. And then you have a PID, which is kind of a self-checking value, which has like 4 bits, and then the next 4 bits are the same bits but inverted, so it doesn't need to be checksummed. And then after that, you'll have some kind of checksummed payload in the case of like a token or a start of frame packet or a data packet. And that'll be followed by some type of checksum, and then you have an end of packet pulse, which is a single-ended 0. And then in the case of the handshake packets, you only have the sync, the PID, and the end of packet. So generating and receiving these packets are what you need to make USB go. There's a few other things. You have to monitor the line states and detect if a device has been plugged in. Anyway, over here, I've been working on this code here. Let me go to the top. Up here, we have these packet codes. Whoops. Okay, right here. So these are all the packets that can get used in a low speed and a full speed system. And these ones that say host are ones that can be generated by the host. And then in response, because the host controls the USB traffic, the device can respond with only basically 2 classes of packets. It can do just simple PID handshake packets. It can do an ACK, a NAC, and a stall. And then it can also send data back. And they have 2 data packet types because they alternate between data 0 and data 1, because that lets you know that you're always getting the next one. Whereas if you got 2 data 0s in a row or 2 data 1s in a row, you're going to have a problem. You're not going to want to acknowledge that because it means there's an error. Anyway, I've got all this code written, and check this out here. Just this part right here really just here. This is the entire receiver. And this can receive any of the packets that a device might send. And it fully checks out their CRCs, whether it be a 5-bit CRC for a token or start a frame packet, or a 16-bit CRC for a data 1 or data 0 packet. This does it all. And it does it with timeouts and also buffer size limiting. So there's no crazy thing that can go on the USB bus that could cause this thing to hang or blow up, because it's completely constrained. It can't get out of hand. So when you get a packet, the first thing you want to do up here is you want to it goes into this first. You're going to wait for a start of packet. And what you do is you just read the lower of the 2 USB pins and test bit 4 to see if you're looking for SOP, start of packet, to go high. And so it'll time out if it doesn't get there, because you have it's supposed to begin within 5 or 6 idle bit periods. And if you don't see anything by 16, then you're done, and then you just time out. So I have the timeout set for 16, actually about 18 bits really. So if it falls through here and then this is true, it means you had a timeout error. If it gets to here though, it means that you've got the SOP in the right time frame, and then it reads in the PID. So it calls to this get byte, which is down here, which has another timeout. This is a little timed out thing. So it checks for one of 2 events. You either get a byte, a new byte that came in, or you get an end of packet signal. And those 2 things can occur about at the same time. So this routine has to be able to detect that you're getting either or. I mean, you could get both of them or one or the other of them before it returns. And again, if it times out, it falls out down here and it pops the return address, writes PID to 0, which means nothing worked, and you're out of here. So then, depending if you get a handshake packet, these are the 3 handshake packets you might get, and these are the 3 data packets. It goes to the appropriate place. Here's the data packet thing here. So it gets rid. Oh, whoa. Data packet comes in here. It's kind of tricky because it has to check. It has to keep track of the CRC from 2 bytes ago, because you don't know when the packet's going to end. So you have these bytes streaming in, then you have an SOP eventually, I mean an EOP, end of packet, but it works that out. It gets all the bytes in. It knows where the last checksum had to end. And then here it compares checksum. If there's a problem, it goes to error. Otherwise, it computes the final size of the packet, and then it returns to you. returns right here. And then this is just the handshake. But anyway, this will get all the packets. Then for the sending side, let's see, the sending code goes down to here. Let's see, this is the entire send code. All this code to receive and send is only 110 instructions. And it does everything without the possibility of things getting hung up or crashed, because it has timeouts where they need to be, and it checks all CRCs, it checks timing. So this should be like, you know, perfect as far as registering USB traffic right and generating it. So these are all the things that it can send. Pre is the preamble that goes to a hub in case you have a slow device behind the hub. You have to send out the packet, but without the end of packet. So we have automatic EOP generation. So here I had to like do that manually, just generate the JK states to kind of spoof it. And yeah, here's the pattern down here for those pre-packet states. But anyway, it'll generate a pre. Here it will send an acknowledge. We can't send an ACK or stall. That's only a device thing. So this is our one handshake we can give as an ACK. If there's an error, you don't give anything. So you either give ACK, meaning it's okay, or nothing means there's an error. Here's start a frame, where it takes the frame number, it increments it, 0 extends it, puts the PID on it, and then jumps down to here where it sends it out. And then these are the CRC5 things, the setup, out, and in. And here it goes to send token. It incorporates the 7-bit address, the 4-bit endpoint, and then it computes the 5-bit CRC, and then it packs it all together, and then it sends it out. And the data, you start with the PID 0 or 1, depending on carry, and then you call this thing down here, byte data, which will send the byte and add it into the CRC. And then when you're done, you just call end data, and it will end the packet for you and do the EOP. So this is like everything that it needs to generate all the USB traffic, both getting packets and then generating any of the possible output packets. So what it comes out to, oh, in this code here, it winds up getting parked in the open register space of a spin cog. So it's not needing its own cog that's going to have to be all PASM. It's like a terminate stay resident program. It just sits there in unused register memory.
That's amazing, actually.
Oh, thanks. Yeah, you mean
because that could make it even smaller, because with the current USB driver that I have, it's all the logic, sort of the slow logic is also in assembly. So it's big.
Yeah, it'd just be huge, right? It would be too big. So this
well,
way,
no, it's something out like 9 kilobytes or something. So it's not like.
Okay. Yeah, well, in this case, see, I can then do like a little, this is spin code right here, right? I can do an org, and I could totally like send out a data packet. This first thing I just put in here to space it, make some idle periods, and then I call send data, and I send, 8 data bytes, and then when I call end data, it tacks on the CRC, sends that, and does an end of pulse. So this generates a data 0 or a data 1 packet, depending on carry going in. So but see, it's calling stuff that's already sitting, that's already loaded into the registers above. So it's it's there. So when I have to do like high speed stuff where I have to have contiguous data, I don't want to have to use spin for that. I just put a little assembly language to put the thing together, and then it generates the packets. Or I can call, get packet. So in this case, I have something generating a data packet repeatedly. This is just kind of junk code that I've commented out. Now up here, I have another cog running that's loaded up the same code into itself, and it's calling the get packet, right? And I have to set the time, because I didn't go through the whole initialization, so I have to set the timeout value for the full speed packet. So when it calls get packets, get packet, it looks to see, because, you know, we're jumping in here at some odd time, it's going to get some junk that's going to air out. And finally, it's going to register properly the packet, because I don't have this thing really coordinated like it's going to be when you're having a real USB conversation. It's just two cogs running asynchronously, but it'll find the packet. And so if it ever gets a non-PID, a non-zero PID, it's going to be C3. In fact, I could just change this to like, because 0 is a packet error, right? So if it gets a good packet, print it out. So if I run this from my, because I don't have my pointers all set up, I'll have to do it from this here. When I run this thing here, you can see that it's getting that C3 packet, which is a data 0. It's counted, there's 8 data bytes that came in, the CRC checked out, and then here are your 8 data bytes. So it's conversing. It's working. So the idea is that I can keep what has to be super fast all in assembly, you know, in little snippets like this that are orged and ended. And then I can make all the high level decisions, which are like inter-packet, or they're like, I should say they're like, what do you call, is it an exchange? Is that the term? Where you have like a whole little mini conversation in USB, and that has to be all timed out. So you can't exceed, you know, so many bit times before getting responses back and forth. Otherwise it's errant.
Yeah,
so,
but when it's idle, you can just wait for however you want.
I wish I could understand what you're saying.
If you're just idle, you can actually wait however long you want to start another one. You just have to eventually do the start of frame.
Yeah, you can start an exchange at any time, but once you're in an exchange where you give it like a setup command and it has to acknowledge you back, all that becomes timed, right? That's supposed to
basically.
But see, the nice thing is that can be just a couple lines of assembly code to make that stuff happen. So you're faster than Spin. But when you're like thinking about what you want to do, you can do all that in Spin too, and not have to, you know, write everything in assembly language. You only write the super high bandwidth stuff, and the thing that needs contiguous timing, that goes into PASM, and the rest can live in high level Spin. Like this.
Speaking of deciding what to do, look at this thing. You may remember this one.
Wait, say that. Try to say it slowly so I might hear you.
You may remember this one.
Yeah.
This used to not work.
Oh, you have a game controller in your hand, right?
Yes, this particular one, I mean. Used to not work, was no good, no good.
Man, I can't hear anything. Everything sounds like it's muffled and underwater. I've tried.
Someone sold his house to Aquaman.
Anyway, the setup what you do in Spin. Let's see. There's some setup stuff like this right here, where you have to give the lower level driver what your base pin is, and then set up the thing for like both pins. You know, pin A, B, and you set up the for full speed. This would be actually like C, because you want, is that right? Let's see. Yeah, host and full speed. Yeah, that should be C. Anyway, and then you set up your timeout. So I have like 18-bit periods for high and low speed, and then you can initialize your frame number, your address endpoint. And I also have a little sniffer program that runs at the very end here, which is like just this little thing down here that just monitors. It can read the smart pin and then throw the raw signals out onto 16 IO, so I can pick it up on my logic analyzer and watch from a third cog just the observation of what's going on with the USB status and everything. But anyway, this code here, this is the stuff that I've been working on. This is 110 longs of code. and it does all the low-level conversation stuff with every check and every CRC and every timeout, everything that matters. Okay, so I'll stop sharing this now. Okay.
Oh, I have an idea. I have amazing idea. Create new file. Share screen. We're gonna do this. We're gonna do this old YouTube tutorial style, right? Where's my window? There we go. Imagine
Ada, I can actually hear you a little bit better now for whatever reason.
Today.
Chip, I don't know if you saw my
no,
message, but you might try
wrong.
calling in on your phone to hear better. I don't know if that's
that's another thing.
Jim, I can kind of hear you, Jim. You said, go ahead.
You might want to try calling in from your phone and mute your computer and just have the phone for your audio.
Actually, I can hear you perfectly for some reason.
I think you might have a bandwidth issue, maybe.
No, oh wait, hold on. My microphone. Where'd my microphone go? Oh, it's right here. Jim, I can hear you just fine. I think Ada's, for some reason, Ada's audio is hard for me to hear.
Is my audio busted?
Okay, that's better now. It's better now.
Anyone else?
I can hear you clear.
Sounds fine to me.
Okay.
No, like weird distortion because it's overdriving or something.
I can hear everybody fine.
Okay, it seems like I'm hearing everybody okay now.
Anyways, the thing with the funny controller here, this used to never work on the P2. And I've finally figured out why this doesn't work. Do you want to know why it didn't work? I posted it in the forum, but I have to say it again because it exasperates me. You have to ask for a string from the device. It doesn't matter if the string actually exists. You know, like the strings where the device tells you what it's called. It doesn't matter if the string index you're asking for actually exists. It will not give you data unless you ask for a string first. I have no idea how this happens, but I figured it out. But now now it works.
Yeah, the way USB works. I mean, at the bottom level, you have this packet exchange going on, but there are two other levels to the software. One is there's some protocol for what you put into these packets for certain things and making low-level requests. And then once you identify what class of device you're talking to, you then have to know about that device class's data structure so that you can then query and learn about functions that device
we already have that. But the problem is, if you actually send the in packet to this thing, and you haven't asked for a string yet, it will just give you a NAC every time. You have to ask for a string first.
I mean, is that likely just a bug in the particular USB device implementation of the particular controller?
Possibly. They may have some sort of bizarre intent with that, but I say it's a bug, probably. But now, after I added a pointer string request into the driver, let's see where we're now. Of course, this problem probably never manifests on like an actual PC, because they always ask for the strings, even if you're not looking at them. But we don't have the memory for the strings, and we don't really care about the strings, so we never ask for the strings. And now we ask for one string, we ignore the results, and this makes this work. So that's just an anecdote for USB exasperation.
Yeah, it could be a bug in the particular device, or it could be that device is the only one that you have that actually implemented the whole HID gamepad protocol, correct?
No, this isn't even using HID. Right now this is using the X input.
Oh, okay. So
that's not even real HID. Mind you, there's a reason it's not real HID. So the problem with the real HID is that it has a very complex structure that tells you the report format for that particular device. However, it doesn't tell you what that report actually means. You know, you have some buttons, but they just have numbers. like you don't know what the button is, this will lead to something like this, where the buttons are just numbered on the actual thing. Because that's the only thing the computer will know about it, is there's some buttons.
Yeah, you don't know how they're, you know there are buttons, but you don't know, and you know what bits the buttons will be reported into, but you don't know where the buttons are on the actual device.
Exactly. And if you have something that's an X input device, not only do you know where the buttons are, but you also know what the button is. You even know the letter that's printed on normally. This one actually doesn't match the X input spec buttons. Bizarre, right? But at least you know that that's like the left button or the right button, or the east button, south button, I call them usually. And you know that that button. And everything suddenly becomes very easy. Because if you look into like older computer games, older PC games that support controllers, they all have a menu somewhere where you have to set up which button is which before you even play the game, of course, which is very interesting. And ever since this nonsense was introduced, they've stopped having that. But there's a story of a strange innovation. Of course, because Microsoft are idiots, it's not actually a full replacement for all the same functionality. So you get this, I'm not sure if you're seeing this, but there's a switch here that says X and D. Yes, you can switch this between standard HID, which is D, and proprietary nonsense, which is X. Cool, right? It also has a mode button on the front, because there's another deep exasperation with these things. So remember GamePort? On GamePort, you always have the directions as analog inputs, even if it's just the device just has a digital input like this, because it only has a certain number of pins, so they just did it like that. And so they kept doing it with USB devices, because all the games were sort of hard-coded to look at the XY axis from the input device. And when these came along that actually have actual axis, they now have to have a mode button, so that when you have a game that only looks at the axis, you can set this mode button, and it sort of swaps these. So this becomes the hat control, and this becomes the axis control. Despite this being analog and this being digital, it sort of makes both digital in strange ways. But that's what you need to do to make it actually work with the old game that is hard-coded to look at it. By old, I mean they were still doing it in like 2010 with like the RPG Maker. Don't ask me how I know that such things. And of course, if you have one like these, this one always does this, because it doesn't have any analog axis, it just has this, so might as well.
So
anyways,
I have a question for Chip.
Yeah.
So I mean, it looks like you pretty much cracked the code on the low level interface, the very timing sensitive stuff for USB slow and fast, I guess, or what's it called, full speed and normal and full speed. So, I mean, in order to incorporate that code as the lower level within a fully featured USB stack, it seems like we could probably use one of the open source off the shelf embedded USB stacks and just make that substitution. You know, swap out their low level code for this PASM code and compiled in FlexSpin, and then have essentially a library that would replicate the functionality that you find on, for instance, the Arduino platform or whatever for USB support. Am I missing something in thinking that, or?
No, that might work, yeah, because we have some stuff in the smart pins that does the the actual serial shifting and the bit stuffing and the bit unstuffing, and generates all the little signals that make up a packet. And then we have this little bit of PASM code that drives that to make it all happen. So yeah, but what goes on top of that gets more complex, because
ridiculously complex.
Yeah, I mean, you have to like maintain a live database of what is connected, and you
Yeah,
have
that's
to
a big
like,
issue. We're actually not doing that in USB New right now, to a very nice extent. It's a giant mess, sort of figuring out what's connected. That's why you can only have one level of hub. You cannot plug two hubs into each other; it will just explode.
now two levels of hub is possible, right? I mean, the protocol supports that, right?
Yes, but the problem is we have to keep track of which device is where. And it's a lot easier if you only support one hub, then because you can then say, oh, it's on port 0, it's directly connected to the P2. If it's on port 1, it's the first port, and that like that, you know?
Right. And there's issues like if you get a keyboard with a mouse connector on it, it actually looks like a hub. And it's going to have a hub.
Not really. It's if you have a keyboard mouse combined device, it's actually two interfaces on one device.
They could be a single HID then.
No, that's two HIDs, but one device.
Okay.
Right, you can have multiple interfaces on one device.
So you'll query this thing and know that you're talking to one device, but it has
two interfaces, right?
Two interfaces.
Exactly. Yeah, but there can also be multiple devices with multiple sort of sub devices within one interface of one USB device. Check out this odd contraption here. So this is, I have to surely backpedal to get the example. So what you have here is, ignore the second USB plug on the end. It's bizarre, but you have these 4 sockets here. And what you plug in is one of these GameCube controller. And they have this bizarre plug. Bizarre. And you plug it in here. And this funny adapter box turns it into a USB HID somehow. What this actually does is even weirder. It has one HID device, but it uses, through some means, the report ID to sort of differentiate the 4 different actual sort of controllers that you can have plugged in. Also, and this could, if it wanted, this could have like a keyboard and a mouse on it as well. And also a storage device if it really wanted. It could have all of this in it.
Yeah.
And then you could plug this into a hub, right? And when that's plugged into a hub, that might be plugged into another hub.
Yeah.
And you know, that's sort of the spiraling complexity of this.
Yeah. Can Ada, would you allow me to share my screen real quick?
Oh, yeah, it's still going.
I wanted to finish my thought here a little bit. Are you all seeing a GitHub?
Yeah,
we are.
Yeah.
Okay, so this is the GitHub page for Tiny USB, which over here on the about it says it's an open source cross-platform USB stack for embedded systems, MIT open source license, and of course there's some documentation right here and some more on the link. But I wanted to draw your attention to this little graphical image of the modules that Tiny USB provides. And what I was trying to say, and was not probably getting across very clearly, is that maybe chips code occupies this MCU port part at the bottom of the stack and provides everything we need to basically move Tiny USB onto the P2. And as you see here, it's 95.2% vanilla C code, only 0.5% C++, and the rest is probably some build support functionality that we don't really need once we adopt the build system to the new environment, I would think. But I mean, if it's 95% vanilla C code designed for embedded devices, it probably would compile in FlexBin, and maybe that's a pathway to a pretty full-featured USB stack.
Yeah, that sounds like an idea if you want one that has more than like the very basic things that we're doing right now. So it's probably going to be larger, right? If it's more general.
Yeah, I mean, I don't know enough about it to know like how configurable it is. Like, can you customize your build to include just what you want? But here's a list of the device stack that it supports as well. And
Video
yeah,
class work in
it's
progress.
extensive,
Okay.
but maybe it's configurable to leave
Because
out
this crappy webcam that I have here actually is a USB 1.1 full speed device. That's why the video quality is so crappy. And this sends out frames in motion JPEG format. And I've also already made a JPEG decoder. Could do something with that, just thinking random things.
Yeah, I mean, there's a lot of stuff here for the taking if it can be integrated. And if, you know, I don't know enough about programming in C with FlexSpin to know if we get the benefits that Chip was describing, where you only really have to bring this low-level timing critical code.
The problem is that it doesn't really have the bit where you can.
Go ahead.
Well, usually it compiles the assembly, the high-level code, so you're actually better off writing that in assembly directly, because then it'll be much smaller. It has the bytecode support for P2 is sort of very different from what Chip does, and it's kind of oddly experimental and buggy. I'm not sure if it has the capability to load that extra stuff and keep it resident. I don't know. Eric knows that probably.
Yeah, it just seems like there's so many pluses to Chip's implementation that, you know, certainly there's an approach to build a lot of Spin2 code above that to support like all these different types of devices, but it would seem like a much faster route to having a fully debugged implementation to maybe use something like Tiny USB. But
look at what I have.
That was my thought. I just wanted to finish the thought, basically.
It's an awful unit. It is a PS2 to USB adapter.
Yeah, that, you know, when
two things you plug in.
When something plugs into a PC, I'm sure megabytes of code execute. And then it starts looking around for like the
Actually, not that much. I've actually looked into for the aforementioned controller issue. I put it into frame again. Well,
it's gonna.
I've actually looked into the Linux driver that for these things. It's somewhere in the kernel source tree. You can actually look at it. It's called xpad.c, and you can actually look at that, and it's not that much. Of course, it calls into the input subsystem and into the USB subsystem because it's sort of the connecting layer in between, right? And the actual transaction isn't very much either. It just basically asks a bunch of things, including these strings that magically make this work. But also, more importantly, the device descriptor. It somehow figures out which driver is supposed to do this, which I think it just does by asking each driver, is this your child? Is this your child? He made a big poo in the play area. And eventually one of the drivers will pick it up. And then it just kind of starts talking to it. It's actually not that complicated.
Well, what they're going to do is they're going to look for the product ID or the vendor ID and then the product ID and probably use that as an index to pull in some driver, right?
Generally, you can either use the ID to pull in a driver, or you can also just look at the device classes, interface classes. If something says that I'm a keyboard, I have hit class and I'm a keyboard, then you can just say, oh, it's a keyboard. I don't even care about who made it. And that's how you get all the keyboards, for example, including things that aren't really a keyboard, but like we call them a keyboard because they have a keyboard plugged into them. There we go. There it is.
Yeah.
And a mouse. Look what I found. It's a PS2 mouse. The only one that still works that I could find in the bin. And yeah, I Again, if you wanna find one of these, look at this beauty. This is a real 7-port hub, as opposed to all the fake 7-port hubs that are actually just a 4-port hub, and then there's another 4-port hub connected to it.
Does anybody know what being a host for a communication device class implies?
I think you just look at the communication device class specification. Is probably the answer, because I don't have no idea.
Okay.
Yeah,
Probably has some setup, but if it's actually set up, you probably just send the bytes into it and does it.
I think like these USB to serial converters would fall under that classification, right?
But it actually lists that as a separate class, Chip. It lists under the host classes that are supported, it has both vendor serial over USB for example, FTDI devices, and then separately it lists this communication device class. So I don't think it's serial devices, it's some other type of communication.
Well, CDC is serial over USB basically, or serial over Bluetooth if you really want to. Fun fact, a lot of Bluetooth is basically just USB but wireless.
Yeah, well, it's all kind of glorified serial port.
No, I mean this in the sense that the same interface classes that you get over USB, you get over Bluetooth.
So looking at the wiki page, if that can be trusted for communications device, it talks about things like modems, fax machines, telephone.
Well, what is a modem other than the serial port with a really long wire?
Yeah, I mean, I guess at some point USB modems existed to plug into landlines. So it's
yes, of course,
that type of device, or a USB connected fax machine, apparently.
I mean, I have a network connected fax machine.
Yeah, early on DSL modems were even USB.
Okay, I vaguely remember that. Yeah, and they'd also talk about CNC machinery using it probably as a replacement for RS-232. So yeah, I guess it is similar to the serial. It's a serial port replacement type of technology. But yeah, I mean, if you imagine a P2 as a host with a hub, so you only need one USB port on the P2, and then you have a hub, and then you just have keyboard, mouse, and a mass storage device that runs fast. I mean, that's a lot of capability right there.
Well, I mean, we've got the keyboard, we've got the mouse, we even got the silly game controllers. We already got a lot of that working. It's very proven technology.
Check this
For
out.
storage device, well, we have the SD card, which is actually better.
My wife went to this store called Falling Prices, where they get a bunch of Amazon returns by the, container load probably. And then they on Monday they put all the new stock out. Tuesday everything's $6, and then Wednesday it's $4, $2, $1, and then on Saturday everything's 25 cents. And then they reset everything on Monday, and Tuesday they start at $6 again. So anyway, my wife got these it's a 10-pack. I took 2 of them out of here, but these are 4 gigabyte USB drives she got for $2.
Wow.
If it had more than 4 gigabyte, I wouldn't have trusted them.
Well, they're 20 cents each.
Crazy.
Yeah, I mean, you often get these flash drives that say 2 terabytes on them. And if you plug it in, it says 2 terabytes. But it actually sort of just masks off the top address bits. So eventually, if you fill it up, it'll sort of wrap around on itself and everything corrupts. Amazing technology.
Well, go ahead.
No, I'm sorry, Chip. I didn't want to interrupt you. I was just going to say, I know you have kind of a history with the old 8-bit computers back in the day. I believe the USB standard was one of the guys that sat on the board for it. Actually, is the one that invented the SIO port for the Atari 8-bits, like the 800s and the 800 and 600 or whatever, 400. But a lot of the technology from that actually got got put into the USB standard initially. It was the same guy that worked at Atari that eventually ended up working on the USB committee or whatever back in the 90s.
Interesting. The spec I'm reading that I'm going off of is the version 1.1 spec for full speed and low speed devices, which are 12 megabits and 1.5 megabits. And it was made in 1998. So it's a 25-year-old spec.
Actually, you probably want to be looking at the 2.0 spec at least, because the USB version is not necessarily synonymous with the speed class. So there's certain features, I'm not entirely sure what, but some things that are in USB 2.0 that also apply to full speed devices.
Yeah, well, they didn't. Yeah, they have some new PIDs for high-speed devices.
Yes, high-speed is a whole separate thing, but this USB hub here, this is full-speed USB hub, but it's actually a USB 2.0 device.
Right.
So if you plug it in, it will say it's a USB 2.0.
But in a case like that, if that plugs into a full-speed host, it's just going to behave like a full-speed device, right?
No, it is a full-speed device. It is a full-speed USB 2.0 device. It is conformant to the USB 2.0 spec, and the device descriptor tells that, but it is a full-speed device. It does not have any high-speed abilities.
Okay.
That's what I'm talking about. High speed is not mandatory for USB 2.0. Also interesting, USB 3.0 is a completely separate thing. You see those extra pins in like a 3.0 port, which I don't have here, at least not in a form that I can dangle in the camera. That has 4 extra pins. They're called TX plus, TX minus, RX plus, RX minus. And you can actually connect these completely independently of the regular D plus, D minus. And will just work if it's a super speed capable device. It actually doesn't care about the D plus, D minus at all. You can actually connect them to a completely separate device and have 2 devices running off 1 port with just passive wires, which is bizarre. Also, if you have like one of those new Macs, apparently they have like this awful off-spec USB, where if you plug in too many hubs, it will actually stop working far before a normal computer would. Because their USB implementation is absolutely crap and shitty, and will like crap out after like 2 hubs instead of the 7 or something that it's supposed to do. Absolutely amazing. But you don't notice this if you have if you're only using the USB 3.0 devices, because they use a completely separate thing.
They've integrated the high-speed video for
all that is
USB spec.
Say that again, Greg.
So they've integrated a high-speed video controller over the USB 3 implementation on the Mac. There's 2 ports that are special ports on it. And like she says, it can really get out of whack really quick. You have to buy a special cable. The cable costs like $50, and you plug it into this thing, and it'll drive a 5K TV set off of it.
The video thing is something completely else. The video thing is where you decide. So on the USB-C plug, which is the one that looks like, I have one, which is the one that looks like this. You actually have a TX1 and a TX2 and an RX2 and an RX1, not in that order. And what that does is, what you can do with that is you can actually negotiate over, I think, a separate line that you don't want to use these as USB 3 or USB 3.1 or whatever it is, USB transit lines. You can actually configure it so you can pass DisplayPort or HDMI signals over those wires.
Right.
Because remember, an HDMI signal that has 4 main things: the clock, the red, the green, the blue. So you can actually just pass these over a USB-C cable / plug. All the rest of the things gets tunneled through USB other things somehow. And So that's how that works. The USB plug can actually be something completely different when it decides to be. And of course, there's like 50 different things that it could be, and like trillion different standards on how to accomplish that. So if you actually try to plug something into a random thing, it probably doesn't work. Deeply interesting stuff that happens there.
Was there anything anyone wanted to talk about besides USB stuff?
Don't think so.
Oh, about USB stuff. I had another question about USB stuff.
A quick question, if I may just interject, and then we'll go to USB stuff. Ada, how would you, or anybody else listening, how would you prioritize the features next for things that we want to see in VS Code?
Wait a second. Say that again, Stephen. I'm sorry.
There's a list of features that I haven't implemented in the extension yet. I'm wondering what the group's prioritization might be. We have
jump to definition.
Exactly.
Yeah, I heard that one.
He gets
we can do that.
No, that's honestly, yeah, that is what I miss pretty much, because I'm used to it out of Visual Studio and kind of stumble upon it.
Nice.
Okay. Perfect work. Perfect work. I love it.
Anything for code folding? Do people want that?
I don't think I ever like fold the code.
Okay. That's your how to collapse regions of code so it's not on your screen.
Yeah, I know what it is, but I never do it because it's confusing.
Okay, good.
I do like it, honestly. But I'm used to kind of long source code. Cobol source code is long.
Yeah, if it's a very long file with a lot of methods in that, a lot of times I will fold things up.
Yeah.
In the Propeller tool,
please.
Yeah, on the Propeller tool, when you compile, it shows you like a little graph of how much memory you have. And I know I don't know if that's something that Peanut replies with, or is
Peanut
there any
does
way?
the same thing. Yeah, let's see, if you do in Peanut, let me see here. I think it's an F8, F9. Yeah, it shows you that graph.
Yeah, is that something that can be brought into Visual Studio Code, or is that something you just get in the terminal window when you're done with your compile?
We don't know. We could bring it up through the command line, and then you'd hit OK to dismiss it. That'd be an option.
I think FlexBin recently added the ability to print out the actual component sizes, which I think it never did before, except for bytecode mode. What I'm thinking is that it could probably be, we could probably put a graph right in the terminal, just like that. Would need some cool xterm commands or something. Or maybe just hope that the terminal is Unicode and put out some box drawing characters.
Yeah, it wouldn't even have to be that fancy looking. It could be just, some kind of character across the terminal.
I mean, text you can always get. Text is just but that's not really visual in the same way.
Yeah, it was just always nice seeing that. Yeah, it just was kind of nice to see that.
I mean, thing to just cold drop into Eric's pull request box, and then I don't know.
Yeah, or let Peanut pop up a window. Peanut needs to compile it again and then throw up that window, command line switch.
Yeah, we can have a command line switch that does it. Look, let's see here.
Yeah, that'd be awesome. That'd be perfect.
Here's the little thing it throws up.
Yeah, and then if you don't want it, you don't send the command switch. That's perfect.
Well, Peanut has the neon color version of this.
Yeah, that would be it.
Yeah,
Yeah, the Propeller tool always had a bit more nicer colors for this, I think.
And on the Propeller tool, wasn't there a way to view the actual the contents of what was in the hex file? Not that that was ever really.
Yep.
But it was just nice to see if you wanted to check for something. But
yeah,
sometimes you could see interesting stuff down there.
Peanut generates a list file which has lots of data in it.
Is that like a map file from like?
Well, yeah, it shows all the symbols and what they resolve to and what types they are, and then it shows how many object bytes, how many var bytes, what the clock mode is, and then it dumps all the hex data too.
Yeah, in Eclipse with the STM32s, they have a thing where it parses that whole file that the compiler kicks out, and then it lets you go in and actually find a module or a method or a variable and actually see where it is in memory, search for it. I find that useful.
Yeah, we ultimately, I mean, what I think will probably happen is Stephen's highlighter will eventually become a compiler, and Stephen's really good at making it aware of all those things. So that we just have to make the code generator for it. Okay. He's already practically compiling. He's parsing to the point where he's doing the same kind of syntax checks the compiler does. He's just not generating any code out of it.
Yeah, the code gen is actually kind of easy for spin bytecodes, at least for spin 1 bytecodes. It's very directly corresponding to the actual thing. Like if you look in like I've made the bytecode backend for FlexSpin, and in there, if you look at the code, most of that is actually to deal with things that normal spin never does, or like weird flex spinisms that sort of the front end does, that now the back end has to sort of deal with, because it sort of like changes certain things around to be more convenient for the upper backend, but it actually makes it more complicated to express in spin bytecodes again. You can see that out BC where's that. Let's just get rid of this and get rid of this, and then we can potentially share that. So you can see this. So this is bytecode compiler for spin to CPP. This is the main part, and that's about 3,541 lines, including printing out listings and all that sort of thing. As you can see, a lot of this is just like trying to figure out what sort of spin construct maps to the sort of abstract syntax tree construct that that FlexSpin has in it, which is kind of interesting.
Yeah, emitting the bytecode should be quite simple. Just like
the other thing is actually just like figuring out how to do something more optimized. Like if you normal spin compiler, if you type if this and that, it's actually stupid and will compute both sides and then do the branch instead of doing the first thing, then a branch, and the second thing at another branch. So that's what this actually does here. If it says k op token is k bool and if not 0, so if this thing, it says if L and R, that's what we're looking at. It actually just compiles 2 conditional jumps. Because this is the compile conditional jump function. So if you have multiple things nested with and, it will actually compile a conditional branch for each. Interesting. Unless you have this thing where it says extra small. If you ask it to do small code, it will actually do the normal AND operator bytecode thing, because that's actually like 1 or 2 bytes smaller if you go that route. The other thing that this actually does is we've got another file called BC spin1. And this actually defines all the bytecodes and how they're compiled. I'm not entirely sure how does chip even handle this, because this is bizarrely complex. So you have a jump, right? You can have 1 byte or 2 bytes of length, right? Of offset, you know, it's the dynamic length. How do you know if you can make it 1 byte or 2 byte? This is a very weird question, I think, because based on whether your jump is 1 byte or 2 byte, other things might also pass that sort of boundary, and then it sort of gets all weird. So we actually have a strange function that gets called get size bound. And what get size bound does, it computes the minimum and the maximum size that this particular abstract opcode can actually have. And so it sort of goes around asking each object, each opcode, how big could you possibly be, and then use that to calculate the distance of jumps. And if it says, well, even if all the opcodes in between have the maximum size, this one will always be 1 byte, so we can mark this down as 1 byte, and then it sort of recursively figures them out. And well, not really recursively, iteratively figures them all out. And there might actually be cases where it can't figure it out, and it has to force one into the larger encoding. Does this make any sense? No. So this is all just operating on sort of abstract bytecodes. And this is where they all actually turn into the actual bytecodes. Like here we buff position ++, set it to whatever this is. Fun ID. Oh, it's call self. This we actually use this function here to put it into the listing. What this actually calls. It's very funny. It is another 800 something lines, but there's also a header file for this. It's not actually the header file. Maybe it's BCIR that has the exactly. That's the header file that actually does everything. This defines all the things that they exist. This is our favorite. This is called a byte op IR, and it's this awful structure. Where it has all these structs in a union, and that's sort of how it keeps track of all the different bytecode kinds in this way that's sort of vaguely sane. Like VCR mem op attr here. Well, do we want to pop an index for this memory operation? Do we want to get the results back? Do you want to do a math operator if we have one in reverse? This is specific for one for repeat ping. Then what's our base? Maybe we pop the base. Maybe it's P base. Maybe it's V base. Maybe it's D base. That's in this bit field. And then you have like, oh, maybe it's we want a bit, a byte, a word, a long. Bit generally doesn't exist in spin1, but we have it. And then we also have a different size for the modify operation, which is another interesting thing that sort of happens as a result of how the operators work. And other such amazing things that we have in here. Minor.
Yeah, not sure if that helps, Steph. Stephen to put that in Visual Studio Code. I mean,
just vague exposition about how this actually works, which is kind of, it's not that complicated, but it's actually kind of complicated.
So Chip, did you write the original spin interpreter, I guess, or the? So I know you developed the chip, but you also did the all the coding for that.
You mean for the Propeller one?
Yeah.
Yeah.
Yep. I remember when I first got it, when it came out, maybe it was maybe not even a month after it came out, and it blew my mind. A friend of mine came over and we played with that for like 14 hours straight till we about fell over because we couldn't believe how much power there was in a little microcontroller. It's wild.
Oh, cool. Yeah, that was like in 2006, probably.
Yeah. Yep. I was the one, I don't know if you remember, but I was the one that made the little motorcycle display and like a weekend or two in my garage.
Oh yeah, yeah, of course.
And then you saw that, and it was a couple years later when you came to the Propeller Expo, and I had never met you and I never even knew what you looked like. And my buddy and I were there, and there was some strange guy talking about this Propeller too, and he just had way too much information about it I couldn't understand how he knew so much about it. I'm like, I pulled my buddy aside. I'm like, I don't know who this guy is, but he knows a heck of a lot about a chip that's not even out there yet. And then you had your name tag turned around and you were like trying to surprise everybody, and you definitely got us on that one.
I think my name tag probably just got turned around accidentally.
I thought you were doing that to like surprise everybody, because like I was listening to you talk about it. I'm like, either this guy is either crazy or he's Chip. He's the guy that invented the first one.
Maybe crazy, yeah, but not for drama.
It was a really cool event. That was a weird. I think that was the first expo that they did, and you guys had flown in unexpectedly. I don't think anybody that we didn't know anything about it. I think the guy that was running it might have.
Yeah, that was in like Orrville, Ohio, right?
Yep, yeah. And then we were sitting there, you were giving kind of a impromptu interview to everybody, and somebody asked you, what has anybody done with the Propeller that has surprised you? And as you're telling them about a guy that made a video game, and then you're like, yeah, there was some guy that put this display on his motorcycle. And I'm like in the front row, and I just raised my hand and said, yeah, that was me. But yeah, those are good times.
Yeah, today it's like, man, things that the world's gotten, I mean, tech has gotten more complicated, where from what I gather, from what I kind of observe, it's like you can make stuff from first principles, but there's just such temptation to pull in all kinds of inexpensive black boxes which can do certain things, but you don't really need to know how they work, but they may not work that great. It seems like that's kind of like changed, the mentality of everything has changed. And then seems like more of a cut and paste mentality out there.
Yes, all black boxes, all just put them together somehow. Maybe it will work eventually. I don't know.
So
that's how they do it.
Speaking of cut and paste, and because I got to drop off in a minute, where can I cut and paste your USB code from, Chip?
Later tonight, I'm just going to run a few more tests. I'll just make a thread on the forum about it and post the code there.
I think it's already there. A lot of it's already there. You posted it.
Did I? Oh, I think I already had some.
You and Ada have quite a conversation going in there.
Yeah, let me look at that thread. That's right, because we've been talking about. Let's see. Yeah, it's the redevelopment thread. Yeah, I mean, I could just post it in there.
Should we go ahead and stop this recording? We haven't had it yet.
Wait, say that again.
Should we go ahead and stop the recording? It's still going.
Man, I can't hear. It's like muffled. You said, say it really slowly.
Should we stop the recording?
It's still recording, or we can turn off the recording. Yeah, yes. We can turn off the recording. Yeah. You can throw it back to me if you want to.
I did already, I think.
Yeah, if you want to get out of here. I should get going kind of soon too. I got to do some things to get ready for tomorrow.
Do you
But I'll
want
put,
to, does it matter if you stop the recording or me?
I can't hear.
Chat.
You know, it's almost like the RIAA curve was reverse applied to what I'm hearing, because it's like everything is like bass and there's no treble or.
I thought you said it
Remove the
was fine
phono
earlier.
preamplifier from your signal chain.
Hey, Lachlan, hi.
You must have a bad ground or something in your system, Chip, because you said it was working fine earlier.
You had him as standing in a room all day. Everyone would just be chatting nonstop. No one would eat.
Yeah.
Just, you know.
Wait. What did I say? Snot.
Stop.
Yeah, I gotta zoom in. Hold on. Stop recording. Yeah, sure. You want, but who's controlling it now?
You.
Okay, you threw it back to me. Okay, so here we go. Stop recording. Here we go.